conferințe virtuale. Respectiv, înainte de a-i oferi cuvântul domnului director general al AGEPI, domnului Eugeniu Rusu, vin cu următoarea rugăminte din partea organizatorilor și a echipei tehnice. Rugăm participanții care nu vorbesc la moment să-și închidă microfoanele. De asemenea, încurajăm toată lumea să-și conecteze camerele, pentru că atunci avem impresia că este un eveniment în persoană, chiar dacă ne desparte ecranul, dar totuși ne face plăcere să vă vedem, ne face plăcere să vedem reacția pe care o aveți la ceea ce urmează să fie prezentat în cadrul evenimentului de astăzi. Este un prim eveniment în domeniul pe care îl abordăm astăzi și de aceea vom aprecia foarte mult orice reacție pe care o veți avea atât pe parcursul conferinței cât și după. Pentru întrebări, vă încurajăm să folosiți fie solicitarea prin intermediul mâinii ridicate din bara de jos a ecranului, fie prin intermediul chatului. Noi vom încerca cu colegii să urmărim și să dăm răspuns la toate întrebările care vor apărea în chat. Acestea fiind spuse pe partea de organizare, îmi permiteți să-l invit pe domnul director general AGEPI, domnul Eugeniu Rusu, cu un cuvânt de salut. Domnul director, vă rog.
Mulțumesc frumos, doamna Vieru. Salutare tuturor. Mă bucur că s-au conectat foarte mulți la această conferință internațională. După cum cunoașteți, genericul acestei conferințe este Inteligența Artificială, Inovații și Proprietatea Intelectuală, organizată de Agenția de Stat pentru Proprietatea Intelectuală cu suportul proiectului Consolidarea inovațiilor în regiunea Dunării prin cunoștințele de inginerie și managementul drepturilor de proprietate intelectuală, KnowING IPR, în cooperare cu Organizația Mondială pentru Proprietatea Intelectuală, la fel Oficiul European de Brevete și Oficiul Uniunii Europene pentru Proprietatea Intelectuală. După numărul de participanți, avem peste 100 de înregistrări. Din câte văd eu, sunt în jur de 100 de persoane conectate la această conferință internațională.
Nu vă auziți. Domnul Eugeniu, nu vă auziți.
Scuze. Sunt surprins plăcut că anume acest generic a dat interes tuturor, în așa fel încât să se conecteze pentru să aflăm care sunt ultimele tendințe în proprietate intelectuală și să avem careva răspunsuri privitor la inteligența artificială. Evident că tot programul sau evenimentul internațional InfoInvent este despre invenții, cercetări și lucrări din diferite domenii de știință, dar genericul de astăzi este unul foarte important și, cred eu, de interes public. Cu cuvânt de bun venit vreau să ofer doamnei Virag Halgand, din Departamentul pentru Statele în Tranziție și Dezvoltare a Organizației Mondiale pentru Proprietatea Intelectuală. Doamna Virag, vă rog.
Thank you very much, Eugeniu. You hear me well? Yes, thank you. So a very warm welcome to everyone from Geneva on behalf of the World Intellectual Property Organization and our Director General, Mr. Darren Tang. It would have been, of course, much nicer to meet you all in person in the beautiful Chișinău and explore the exhibition, and also the famous GIs that you find all around the Republic of Moldova, as I had the pleasure back in 2015, but hopefully this will be possible in the near future again. I would also like to congratulate Mr. Eugeniu Rusu for his recent appointment, and it is really a pleasure to continue our excellent cooperation with you in your new capacity. And also wanted to thank you and your excellent team for putting in place the arrangements for this conference. Let me also mention our great appreciation regarding the active involvement of the Republic of Moldova in Wipo's work, with the ambassador of the Republic of Moldova to the UN in Geneva, Mrs. Tatiana Molsean, elected and acting since October as the chair of the Wipo General Assembly for 2022 and 23. This is really a great sign of commitment that coincides very well with your 30-year membership to the WIPO. Let me also extend warm greetings to Heli in Munich and Tamara in Novo Mesto. Allow me also to congratulate you.
Gata, am ieșit. Da, mersi, da.
I hear some voices. So, yes, also allow me to also congratulate the organizers of the Info Invent exhibition, which this year gathered participants from 18 countries with more than 400 exhibited works ranging from biotechnology to design. And I had my colleagues also participating in the opening of the exhibitions a couple of hours ago. For several years now, we are very pleased to support AGEPI in organizing the international conference on the sidelines of the Info Invent. I believe it will be now the 5th time that the conference is taking place. Thank you again, Eugenio, for inviting Wipo once more to participate, and thank you to all our other partners, namely KnowING IPR, EU IPO, and EPO. This year, we focus on AI, innovation, and IP. My two colleagues from Wipo will tell you more on AI from two different perspectives. Ulrike, in her presentation on intellectual property and frontier technologies, will give you a more policy-focused overview, while Michel will give you examples of practical application of AI technologies, in this case within IP administration. We will, of course, hear from many other excellent speakers during the conference. This choice of topic does not come as a surprise to us, as the ICT industry is one of the most dynamic branches of the economy of the Republic of Moldova. Among the creative industries, software development is one of the largest sources of revenue to the national GDP, and is the second largest industry in terms of employment. Therefore, we welcome the opportunity to assist this growing industry, but also IP practitioners and policymakers with this insightful conference, and hope that IP will continue to be in the forefront of the growth and further development of the economy of the Republic of Moldova. Finally, in closing, I would like to mention a Wipo tool that might be of relevance for our audience today, which is our AI and IP clearinghouse. This is a searchable database that collects and publishes the main government instruments of relevance to AI and IP from member states, and this is provided by them to us. This could also be especially useful for countries that are considering to include AI policies in their national systems, like, for example, we heard from the Republic of Moldova. With that, I would like to wish all of you an excellent conference, and thank you so much for your kind attention.
Mulțumesc frumos, doamna Virag. Într-adevăr, avem multe proiecte în cooperare cu Organizația Mondială pentru Proprietatea Intelectuală și mulțumim pentru aprecieri. După cum am menționat, totul se datorează echipei AGEPI și partenerilor care au stat la baza organizării atât a evenimentului cât și a conferințelor, webinarilor și atelierilor de lucru. Cu un cuvânt de bun venit acord doamnei Heli Pihlam Jama, dacă am pronunțat corect, director pentru dreptul brevetelor din Oficiul European de Brevete. Vă rog, doamna Heli.
Good afternoon, all participants. I would like to begin by expressing my warmest thanks on behalf of the European Patent Office to Mr. Eugenio Rusu and to his excellent team of State Agency on Intellectual Property of the Republic of Moldova for organizing this event on such an important and recent topic. I would also like to extend my thanks for the collaboration, for the good collaboration, for the preparation of this event, and also for the presentations today to the colleagues from Wipo and from KnowING IPR. The collaboration in this topic is the key for the future success in this new and emerging technology area and IP protection here. AI is, as I said, a very recent topic. It is now something, it is not recent because we have had artificial intelligence for decades, but now in the context of industrial property rights, it is very much discussed. Often the question there is also, what is AI? At the European Patent Office, we take always as basis the definition that artificial intelligence is a broad subfield of computer science that covers many different computational models for solving data analysis problems. Of course, with these features, artificial intelligence is driving sweeping changes across the global economy and society. Since AI is empowered by software algorithms that are capable of reproducing aspects of human intelligence via respective training or rule setting, AI is enabled to solve technical tasks in a flexible and efficient manner, often leading to very relevant innovations. After a decade of advances in core AI technologies, such as neural networks and deep learning, artificial intelligence is now touching millions of lives, and it promises to remain a disruptive force for years to come. Of course, the impact of AI is reflected in the massive increase in fourth industrial revolution related patenting over the past decade. Between 2010 and 2018 only, global patent filings for technologies involving smart connected objects grew at an average annual rate of almost 20%. That's nearly 5 times faster than the average of all technology fields together. We have conducted a study on this, and that is available on the EPO website. But above all, we at the EPO have seen a steep increase in the number of patent applications concerning artificial intelligence-related innovations in the past 10 years. Surely, that is understandable in the case of such a fast-developing technical field, and also when we take into account that according to a 2019 study of the European Patent Office and the EU IPO, European patents gave small and medium-sized enterprises 110% better chance to grow compared to their competitors without patents. Developments in artificial intelligence also have far-reaching implications to intellectual property rights, not only in terms of how AI-based tools can support the patent granting process to create efficiency gains, as will be discussed today, but also, and crucially, from a patentability perspective. So I'm very delighted to say that in the EPO's experience, the patent system in its current form is fully equipped to deal with the legal issues arising from inventions involving artificial intelligence. Because artificial intelligence is considered a branch of computer science, inventions involving artificial intelligence are considered computer-implemented inventions in the patent law terms. You will later today hear more from my colleague, Mr. Moorman, about the patentability assessment of patent applications related to artificial intelligence innovations. One aspect of patents and artificial intelligence, which has gained a lot of public attention, is the question if artificial intelligence can be seen as an inventor. If artificial intelligence can invent independently. Following test patent applications, as the representative has called them, naming a connectivity AI system called DAPUS as the inventor, most countries where these applications were pending, to mention, for example, the US, the UK, Germany, and Taiwan, as well as us, the European Patent Office, have rejected the application on the basis of the understanding that the inventor of a patent, of a patented innovation needs to be a human being. This is closely linked to the concept that the patent is a right and the society is not giving rights or obligations to machines or computer programs for the time being, at least. This is also related to the principle of human-centric approach applied in Europe and also reflected in the most recent actions and legislative proposals of the European Union organs. I need to say that the decisions concerning the DAPUS applications in most cases have been appealed. Most recently, just last week, the German Federal Patent Court stated that the human being needs to be the inventor and nominated as such in the patent applications. If an AI system has contributed, that can be additionally mentioned, but doesn't replace the human inventor. At the European Patent Office, our legal board of appeal will take a decision on the same question later this year. The developments in the artificial intelligence technologies and the need for information concerning protection of innovations are important for the European Patent Office. That's why my colleagues and I are very pleased to be today at your seminar, looking forward also in the future to continue a fruitful cooperation on the topics of today's event. Moldova is one of our first validation states and as such a reliable partner to us. At the EPO, we have been organizing conferences and events on patenting artificial intelligence since 2018 and are planning further training opportunities for the future. We also communicate by regularly updating our guidelines for examination since 2019 with artificial intelligence and patentability related content, since we believe that knowledge sharing, transparency, and awareness of patenting artificial intelligence related innovations and those practices will ultimately lead to a greater legal certainty and a much stronger IP system. Thank you very much for your attention.
Doamna Heli, mulțumim. Într-adevăr, cele invocate am fost spectatori a dezvoltării colosale din 2010 până în 2018, ținând cont că industria a fost dezvoltată într-un termen foarte scurt și de 5 ori mai repede. Sper că întrebările care ne frământă pe fiecare le vom găsi răspunsul la aceste webinare și ateliere de lucru. Ținând cont de problemele cu care se confruntă doamna Tamara Valic, liderul proiectului KnowING IPR, vreau în primul rând să mulțumesc proiectului pentru suportul acordat AGEPI-ului. Dacă doamna Vieru poate să mai adauge careva cuvinte în vederea cuvântului doamnei Tamara Valic.
Vă mulțumesc, domnule director. Într-adevăr, AGEPI-ul este partener al proiectului finanțat în cadrul programului transnațional Dunărea, și anume proiectul KnowING IPR, consolidarea inovațiilor în regiunea Dunării, prin cunoștințele de inginerie și managementul drepturilor de proprietate intelectuală. Suntem unul din cei 20 de parteneri ai proiectului, care se implementează începând cu 2018 și va finaliza la sfârșitul lunii decembrie, de fapt la finele acestui an, și care sperăm va lăsa în urmă un rezultat, un produs extraordinar, care este platforma KnowING IPR Hub. Este un produs informațional de o mare valoare, având în vedere că este acea platformă pe care incorporează în ea atât informația de brevet conținută în cele mai mari baze de date, și vorbim aici de bazele de date de brevet ale Organizației Mondiale de Proprietate Intelectuală, ale Oficiului European de Brevete, ale oficiilor naționale participante în cadrul programului Dunării, dar și un lucru extraordinar pe care echipa de proiect KnowING IPR a reușit să o facă este faptul că avem în această bază de date sau pe acest portal și informația ce ține de literatura non-brevet. Cele mai mari colecții de literatură științifică, literatură tehnică, articole în domeniul tehnicii sunt posibile de vizualizat, de consultat, de accesat prin intermediul platformei KnowING IPR Hub. Proiectul urmărește facilitarea accesului bazat pe necesitățile inventatorilor, a cercetătorilor, a oamenilor de știință la rezultatele inovării și cercetării, la informația de brevet și informația non-brevet, la tot ce înseamnă serviciu de proprietate intelectuală, datele de proprietate intelectuală, iar la crearea acestei platforme a fost necesar să fie utilizată, desigur, și inteligența artificială, subiectul care este astăzi cel mai important în cadrul discuțiilor și dezbaterilor, atât pentru participanți cât și pentru speakeri. Ne-am adunat aici ca să vedem cum poate inteligența artificială să contribuie la îmbunătățirea serviciilor de proprietate intelectuală, în special în ceea ce ține de serviciile de colectare, procesare și prezentare a datelor DPI. Iar doamna Dolores Modic, colega noastră din proiect, va veni cu o prezentare în detaliu a ceea ce a reușit proiectul să realizeze și care sunt tendințele și care sunt acele noutăți pe care le-a utilizat echipa proiectului pentru a pune la dispoziția publicului o platformă gratuită destul de complexă. Vă mulțumesc, domnule director, și în numele liderului de proiect ne cerem scuze pentru problema tehnică care a apărut între timp. Mersi mult!
Mulțumim, doamna Vieru. Acestea fiind spuse, procedem nemijlocit la Conferința Inovațională Internațională cu genericul Inteligența Artificială, Inovații și Proprietatea Intelectuală. Transmit ștafeta către moderatori. Moderatori vor fi domnul Andrei Popa, director general al AGEPI, cât și Richard Frelec din Departamentul pentru State în Tranziție și Dezvoltare a Organizației Mondiale pentru Proprietatea Intelectuală. Richard, sunt bucuros din nou să te revăd, la fel ca și pe doamna Dirac. Păcat că ne vedem doar în online, dar sper că timpurile se vor schimba. Vă urez mult succes și raportorilor. Domnul Richard, domnul Popa.
Mulțumesc. A very good afternoon to everyone. Let me just quickly join Virak and say thank you to you, Mr. Rusu, the excellent team in AGEPI, and all the organizers of the event for inviting Wipo to this important conference. I have to add, of course, that after visiting the Republic of Moldova many times in the past, including also during the Info event and exhibition, I only have one regret today, that we can't meet yet again in person in Chișinău. It will be my pleasure to moderate together with Andrei this first session of today. So during the next 1 hour 45 minutes, more or less, we will hear presentations from our two excellent speakers. after which we will have a time for questions and answers. And if I may say, for the topic of this session, which is AI and innovation, with its role, impact, developments, and trends, the questions are actually countless. Without even hearing the presentations, I already have so many questions I would like to ask. But don't, as participants, but don't let me be the only one benefiting from this possibility to ask questions to our two global experts in this exciting area. I don't know if Andre would like to say a few words as well. I know that we are supporting each other as well language-wise. So eventually, of course, there will be a moment if Andre will join us as well. But then, if that will be a later moment, let's kick off with the first presentation from Ms. Ulrike Thiel, the Director of IP and Frontier Technologies Division in the World Intellectual Property Organization. Ulrike is the person in Wipo to ask all policy questions related to AI, data, or Internet of Things. It's no surprise, since even before joining our organization, she had a very extensive legal practice, but also obtained a technical background with a PhD in chemistry and MBA from Oxford. A small kind reminder from all the organizers, and I'm not even sure if I followed it correctly. Please, if possible, kindly speak as slowly as you can because of the interpretation. Ulrike, as always,
limba română este puțin mai lungă decât limba engleză și
and Frontier Technologies, the floor is yours.
Thank you so much, Richard. Thank you so much to the organizers. Thank you so much for having me. And I will start with a caveat. While Richard rightfully says I am the person to ask the question, I'm not sure I'm the person to answer the questions, but I will do my very best in the end. I will attempt to share my screen for a little presentation. Let me know if that worked. Can you see my screen?
Ulrika, could you come a bit closer to the mic? Maybe the sound is more difficult for the translation because we are overlapping with Romanian translation. Is it possible for you to be closer to the mic?
Well, this is my mic.
Okay.
I'm about 10 centimeters.
Okay.
Is that okay?
Yeah, that's much better. Yeah.
Okay, I will try very hard. And for the interpreters, you can stop me at any time, and I will try and move closer. I have a bad habit of being very animated, so I might forget. Just remind me if the sound goes. So thank you again for having me. Thank you again for letting me open a fascinating topic for you of frontier technologies and IP. And what I thought I'll do a little bit is I take you on a tour of frontier technologies, why IP matters for frontier technologies, and also what frontier technologies can do for IP. And then I'll finish a little bit with an overview of what Wipo is doing, but I know one of my colleagues will also give you a better picture later this afternoon. As many have already said, and we're only just beginning the session, it is a field with a multitude of questions, most of them unanswered, but I really think having the opportunity to discuss, to raise awareness, to get together and talk about it like we're doing today is going to bring us miles ahead forward in looking at the different issues that is facing the IP ecosystem. What I will do, as I said, is look at IP and frontier technologies and why IP is increasingly important in our rapidly changing, digitalizing world. And then what I thought I would do is I'll shine the spotlight on two particular aspects in the IP and frontiers technology field, that is AI and data. I know the second speaker in the session will give you much more of a detailed view than I can about AI and patenting. So I will focus on the wider policy picture and the wider picture of frontier technologies, including AI, and how it fits into the policy of the IP system. The second spotlight I thought I'll take you to is data, because data really is a key component that is driving all frontier technologies, including AIs, and I will try and square the circle to get back from data to AI. in order to give you a rounded tour of this fascinating field, including some of the things that Wipo is doing in the field and that I have the privilege to be involved with. I hope my presentation won't take the full lot of time, to give us some more time for question and answers, because I think, as Richard rightly says, there are so many questions, and I hope there will be many more, and much of the value of our conversation today really is going to be the question and the answer and the exchanging of the views. With that, let's be off with setting the scene. I have no doubt at all that anyone getting together in this conference today is very familiar with patents, trademarks, copyright, intellectual property rights. But really taking a step back and reminding us, IP, intellectual property, really is the product of the human mind. Its innovations, its ideas, creations, and inventions. And really, intellectual property rights are what, under certain circumstances, protect those products of the human mind. Human creation and innovation, human curiosity and advancement is what sets us apart as a species. And I say that as a start because that is going to be a key concept for when we look at why AI and IP matter so much in the interrelation between the two. More practically, of course, human creation and innovation drives economic growth and job creation, and in turn is driving wealth generation. Intellectual property rights and the current intellectual property rights system were specifically designed to therefore foster that creation and innovation and hence economic growth.
Sorry, Ulrike, if I can jump in for a kind request for the organizers, if a bit louder, that would be much appreciated by the interpreters.
I will try and creep into
Absolutely. Sorry for that. Sorry for the jump in.
No, and I'd much rather you say than not say. Thank you so much, Richard.
Thanks.
On the second setting of the scene, we are without any doubt living in an unprecedented era of interconnectivity. And pushing the frontier of that new era of digitalization is what I call frontier technologies. And I like to think of them as technologies that operate at the intersection of scientific breakthrough and practical implementation. And it's the merging of these technologies that is at the heart of what we already heard called the fourth industrial revolution. AI, without any doubt at all, remains central to these shifting dynamics. But in truth, AI is only one of very many, a whole universe of frontier technologies, such as the Internet of Things, robotics, blockchain, and others, that are transforming on a daily basis how we innovate, create, and how we do business around the world. From work by Zoom in the pandemic to 5G, cryptocurrencies to telehealth, really the digitalization of our lives and work has been accelerated massively by the pandemic. And I very often think that never before have our physical and digital worlds been more intertwined. AI is currently the most prolific of the new technologies in terms of the number of patent applications and granted patents. If you have not seen it, the Wipo Technology Trend Report 2019 makes fascinating reading in that regard, and it really shows how AI inventions are moving from scientific publications, so from research, into in the patent field of practical applications. However, as I said, it's worthwhile to remember that AI isn't the only one of the frontier technologies. And in fact, if you look at it in terms of market size, the Internet of Things is currently the largest of the frontier technologies. Globally, the number of Internet of Things connected devices is projected to increase almost threefold on pre-pandemic levels to 43 billion by 2023. And we're currently seeing a growth of around 1 million 5G subscribers every single day. The Internet of Things is followed again by market size, by big data technologies, robotics, and then comes AI in terms of market size, 3D printing, and 5G mobile services. One study that came out, I think in the summer of this year, I found fascinating, puts the current value of the frontier technologies global market at $350 billion and predicts that this will increase to 3.2 trillion as soon as 2025, just around the market. Data and tangible assets are the bedrock of our new digital world. And unsurprisingly, in many ways, IP is rapidly gaining increasing importance over physical assets. Innovation creation and IP, without any doubt, go hand in hand. IP is central to driving this economic activity and growth within the field of frontier technologies. And also not to forget, strong IP systems and innovation strategies really will be key to ensure far-reaching diffusion of these new technologies to benefit all and leave no one behind. The IP system that we have today was developed with a focus on human creation and innovation and to encourage the development of technologies that enable production processes and trade of physical goods. The IP system that we have today was also designed when the speed of innovation and creation was significantly slower than it is today. So one of the most important tasks that we face today is to ensure that the current IP system continues to promote innovation in the digital age. Really, and this brings me to what is at the heart of the AI and IP debate. As I said, one of the frontier technologies that we cannot help but see, whether we look in the papers, whether we look into the news, and there's certainly a real buzz in the field of IP and IP practitioners, is artificial intelligence. Why is that? As I've said, human creation and innovation, human curiosity is what makes us human and what sets us apart. And intellectual property rights in the current system that we have were specifically designed to foster that creation and innovation. And that is in very many ways right at the heart of the debate that we're seeing. As it was already pointed out, and as we all know, AI is not a new technology. It is 60 plus years old, but really what is propelling it to the level that we're seeing in the applications, the general purpose applications at the moment, is advances in PC power, better AI models, and the availability of good quality training data. Now, most current AI applications can be described as narrow AI. There is a very lively debate if we're ever going to see general AI, and if so, when. However, that debate aside, I think what is clear that we are seeing is that AI is increasingly becoming more autonomous and that the required human input is decreasing. And really, as the current IP systems were designed to incentivize human creation and innovation, this begs a very fundamental question, and that is, does AI innovation and creation fit into the current IP system? Should AI and innovation and creation be incentivized by the current IP system at all? And if so, where do we put the balance between the value of human creation and innovation and AI innovation and creation? And at this point, this might sound very theoretical, but at this point, I would like to give you two examples, and these are real life examples out of the copyright field. There are already a number of companies that are using AI models and libraries of millions of music samples to basically generate the soundtrack of your choice. You select the music genre that you would like, you press a button, and a few seconds later comes out your own personalized soundtrack. And this is not fiction. AI generated music is being used as part of advertising jingles and part of soundtracks on an almost daily basis. Now, with the ability to create large amounts of music pieces at the press of a button with zero marginal cost, should these items of music be treated the same as human-generated music under copyright? A second example. there is a company in Australia called Uncanny Valley. Uncanny Valley is a music production company that uses AI, and they won the AI Song Contest in 2019. The AI Song Contest is basically a version of Eurovision that I'm sure we're all familiar with, gone AI. So the idea was to feed every single song, a Eurovision song that was ever created, into an AI model and come up with an AI-generated piece of music. However, what Uncanny Valley did is it took a concerted effort of the production company to select one of the music pieces coming out, to master it, to supplement it with Australian sounds of Australian animals and certain instruments. Should this piece of music that was generated with AI be treated the same as human-generated music? And really, if you do think that a line should be drawn somewhere, where do you think that line should be drawn? There are, of course, also really important questions of how AI can enhance the current IP system to make IP more accessible, relatable, faster and more efficient for the benefit of everyone everywhere. That is a topic that my colleague will get to later this afternoon, so I will leave that aside. Staying on the policy side of AI and IP and how AI fits into the current IP system, I sometimes hear AI as being referred to, I think that's being referred to as another technology, just like photography, to which the existing IP system will simply adjust. But unlike photography, AI implicates every single IP right and every part of the IP system. Not just copyright and the examples that we talked about in the music just now. As you may be aware, and again, I think the speaker coming after me will talk about the Davos cases, the first patent applications have been filed that claim invention autonomously generated by AI in the patent field. And if you're shopping on Amazon or on the internet, if you're watching movies on Netflix, then AI will most certainly be involved in the selection of the choices, having implications, for example, in trademark law. These are just a few examples. If you would like to see and interested in the whole list of questions for the IP system, I would refer you to what we call the Wipo Revised Issues paper. It's a fairly dense read of about 7 pages of all questions that AI raises for the IP system that we're currently trying to find the answers to. Even more so, I always like to say it's even more complicated because what is more, IP is not the only angle that matters in the AI discussion. AI raises many questions across a multitude of topics, from ethics to security, from privacy to competition law and beyond. And for me, it is key that the IP policy discussion we're having is cognizant of these different streams of discussion. On top of that, of course, AI is a complicated technology, and the law operates on factual scenarios. And as I always like to say, the devil is in the details. It is very difficult to have an informed policy discussion on IP policy without having an insight in how the technology actually works, because it's very difficult to have a discussion on whether AI can be an inventor without the background of an understanding, for example, on how machine learning works in principle. On top of all of that, AI, like all frontier technologies, are evolving extremely fast. And all of this debate is then also complicated by a fast-moving target of the technology shifting and the discussions shifting. Now, AI relies, as I said, the current increase in AI relies on PC power models, but most importantly, the availability of data. Data is, of course, also key to all frontier technologies. So let me shift a little bit from what I'm going to say from AI to the topic of data in the next few slides. I am sure you have heard the quote that if digitalization is the engine of the future economy, then data is the fuel, data is the new oil. Every minute, more than 500 hours of content is uploaded on YouTube, and nearly 70 million messages are sent via WhatsApp Messenger and Facebook Messenger, also meaning we're slightly lost when those services go down. It is estimated that 90% of the world's current data has been generated in the last 2 years, with over 2,500 petabytes of data produced daily. And I can't even imagine the size of a petabyte. So to put it into context, the digital collection of the British Library, one of the largest in the world, is just over 1 petabyte, and we're generating 2,500 petabytes every single day. As of January this year, there were over 4.6 billion active internet users also generating data, and that is almost 60% of the global world population is now online. So data really is key to all of the discussions we're having in new technologies, digitalization, frontier technologies, and AI. And I think it's really important to understand the quality and the value and the nature of data, because it's only when we understand that can we design regulatory frameworks for these emerging data ecosystems, which are driving all the frontier technologies, including AI. When I say data, it's actually a very diverse set of information we're talking about, and to highlight some of these characteristics that are unique. Data is very difficult to define. If you're looking for it in the definition, you will struggle, because as I said, it encompasses such a wide set of different characteristics. Data is extremely difficult to value, yet I think we all agree that data can hold significant value. It is often available in vast quantities, often at zero or very low marginal costs. Think of example of the social media data that you're generating almost like a byproduct of your online presence. Yet some raw data, such as satellite data or pharmaceutical clinical trials data, can be hugely expensive to generate. Data is often meaningless. Much of the value of data really is being derived when the data is analyzed and understood in context to form insights. Yet at the other hand, it's the cleaning up of the data and the preparing of the raw data ready for analysis that in itself presents the biggest investment cost, not the analysis itself. And despite some of these significant investment costs, data is often described as a non-rival good, the value of which can be with the wider it is shared. I think it is worth bearing in mind when we say data, this might be a very, very large set of because the regulation of data may actually need to be more granular than a lot of the we are currently seeing. Like AI, the regulatory matrix is really complicated. Often when we think of data, we think of data privacy and GDPR-like provisions, yet the matrix for data regulation is much more complex and overlapping. Again, it reaches from privacy to security and competition law, and also not to forget the cultural approaches to access to data. For example, collection of data can also vary extremely widely. Where does IP come into it all? As an intangible asset, data highlights the increasingly important role IP is playing in the global economy. And it raises a number of complex questions for the IP system. While data is an intangible asset, it often does not involve originality or an inventive contribution. Yet data is the oil that fuels a massive wave of technological innovation and is causing huge changes in the creative sector and in the innovative sector. It is this intangible nature of data and the impact it has on innovation and creation which makes us instinctively think about IP and IP protection. Yet when we look closer, the application of IP to data is as complex as the characteristics of data itself. And like AI, the field of data is evolving extremely fast. The volume of data is increasing exponentially at a very, very fast pace. And the technological means for data generation and collection and analysis are also constantly changing. So you have this added layer of technical complexity. Now, when we think of data regulation from an IP policy perspective, regulation generally aims at establishing a balance that is between protection of rights and investment in data on the one hand, and encouraging the free flow of data that is driving innovation and creation on the other hand. However, it is far from clear very often where this balance should lie. Within this complicated system, the interface of data and IP matters because of this. IP can pose both an incentive for the generation of data, for example, by way of trade secret protections or database rights, and at the same time, a hindrance to the access, analysis, and use of data, for example, when data contains copyright protected works. From an IP policy perspective, it may be worthwhile taking a step back also and asking whether data generation, cleaning, processing, and use needs IP incentives at all, and what the rationale of that IP incentive is. I would try and square the circle and bring you back from AI and data. As we said, AI is not a new technology, it's an old technology, but really it's data that is driving AI to become the general purpose technology and the advances in AI that we're currently seeing. So the reason I thought I'd talk about AI and data is because how we're going to deal with rights and data and regulation of data and IP rights and data going forward will be crucial in finding a balance between the competing interests and shaping our future. Now that brings me to the Wipo's work and the work area that I have the privilege to look after on a daily basis. Wipo is committed to support innovation and creativity, to be a convener for discussion, and to provide a forum to contribute to an IP ecosystem that fosters growth of our economies and supports innovative and creative enterprises for the benefit of all. In the field of AI, frontier technologies, and data, that commitment has several strands. To take advantage of new technologies, including AI, to benefit inventors and creators. And my colleague in the next session will talk you through some of the wonderful AI tools that Wipo has developed and is developing. And the second strand I was going to mention is to provide a forum for raising awareness, for exchanging information about IP and frontier technologies, including AI, in order to enable all of us ultimately to make better policy decisions. And the global leading forum for these discussions is the Wipo Conversation. The Wipo Conversation is an open and inclusive forum, and it's open to the widest possible set of stakeholders. In the last couple of sessions, on average, we had 1,600 people from over 130 countries joining us. And I would be delighted if some of you join us in the conversations going forward. We are running 2 to 3 sessions of the Wipo Conversation every year, and the space in between we're filling with extra events such as webinars. One of the main threads of Wipo's engagement in the AI field that I talked about over the past 2 years was certainly the Wipo Conversation. We sought to raise awareness and help stakeholders understand the questions that AI raises for IP, and one of the results of that was the issues paper that I referred to earlier. We also had the second and the third session of the conversation that took a deep dive in some of these discussions. And all of these discussions are available on our website. All the interventions are available, the presentations are available, and it's fully searchable if you're interested in those discussions. Unsurprisingly, given that I didn't just only spotlight AI, I also spotlighted data, it's probably unsurprising when I tell you that the fourth session of the Wipo conversation that we held this year looked at data and IP. And we just recently had a seminar in which, a webinar in which Japan and Korea presented their national strategies in the data field. That was fascinating. Again, that webinar is available on our website if you want to catch up with it. And watch the space, there are more webinars like it coming, looking at the data and IP field. We're currently working on the dates and topics for next year. And I won't give away too much when I say I think an announcement will be pretty soon, so watch the space. We have some really fun and exciting discussions planned for next year. As I said, in parallel, Wipo is also continuing to adopt new technologies, including AI, to our operations to serve our stakeholders. And Michelle will tell you more about it in the second session today. That just leaves me to look forward to what I call to boldly go, what I don't think is the final frontier. I think there are so many open questions. It's such a fascinating field. It's shifting innovation creation, it's shifting how we live every day. We're at the forefront of having these discussions that will help us all shape the future. So please, I'd be delighted if you joined us at the Wipo conversation as the global forum to have these discussions going forward. And for now, just many thanks to listen to me. As Richard knows, before I give the floor to him, I can talk until the cows come home because I think it is the most fascinating field ever. But for now, I just thank you for your attention, Mulțumesc, and I'll give the floor back to Richard.
Thanks very much, Ulrike. I'm really tempted to ask you a question right now. And we do have that 1 minute to do so. So if you allow, I can go ahead with at least one. I have the whole list in front of me, but which I can leave for later. Yeah. But so because in your presentation, you asked if AI is like photography. So this brings it to mind, there was this case with a monkey which took its own selfie by picking up a camera that was laying on the ground in the jungle. And the selfie, which became really popular across different websites, newspapers, raised this question: does the owner of the camera, who left it there specifically for the monkey to pick up eventually, have copyright to that picture? So the court decisions in this issue can have some kind of indications, right? An IP created by AI. Are there perhaps any other guiding court decisions in the world that can provide some input to the AI IP discussion?
Thank you for the question. And the monkey selfie is very often raised as one of the questions. And I think there are a couple of points in there. The first point is, I think it's what I call the two-bucket approach to looking at the question. And one of them is certainly, what does the legislation say right now? And how does it fit into the current legislation? That's bucket one. I think the second bucket is taking a step back and saying, what's the policy behind it? And is it still giving the right incentive? And looking at it from a policy perspective, which is the spectacles that I quite often wear, it goes back to the thing that IP, patents, copyright were put into place to incentivize human creation and human innovation. And certainly in the copyright field, the intention is very much to provide an income stream, or is to provide an income stream for the creator, and the 70 or 50 years plus after the life of the creator, for the creator and the family going forward. So there's a very human-centric element to the system that we're having, which in some ways gives you a gut feel reaction to why the monkey selfie possibly came out the way it did. I mean, clearly the speaker after me, and that's a very nice way of handing over, is there are the Davos cases that are claiming inventions that are solely made by AI. And as I think it was alluded to in the opening, there were most decisions one way, one or two decisions pending the other way, and there are appeals ongoing worldwide. But as I said, from policy perspective, from my side, before we look at the details of what the system currently says, and the colleague from the EPO is telling us, I would give on the way for now in the answer of the question, let's not forget to think about what the real incentive and the policy behind the IP system is, and keep that in mind as we're going forward. So I've basically not answered your question, but I've given you something to think about. Thank you, Richard.
Most definitely. That creates a very nice transition to the next presentation. A very kind reminder from all the organizers and especially from the interpreters. If all the upcoming speakers could speak as close as possible to the microphone and as slowly as possible, that would be very much appreciated. So the next presentation will be from Mr. Abderrahim Moomen, Director, Directorat 1209 from the EPO. With such an extensive expertise in AI, membership of various related task force and working groups, with a PhD in telecommunications and radar technologies, and also experience in branding and HR, I'm really excited to hear your presentation on the issues of patenting AI. So Abderrahim, the floor is yours.
Thank you very much, Richard. It's a pleasure to be here with you all, and good morning to everybody. It's really a very good topic, very close to my heart, and it's also very good to have this talk after the talk of Ulrike, because she set up the scene and the context from the outside. And my talk will be more technical and to give you some views on the inside to see how we deal, what kind of the challenges we are facing as examiners, as patent offices. Let me first try to share my screen and hope everything is working. Just give me a sign if you see it.
Yep,
it's there.
Presentation is up.
Now let me get my notes as well. And then it should be. Okay, you still see the presentation?
Yes.
Okay, so in the coming slides, I will get a little bit in depth into what is AI, what does it really mean, how we look at it from a technical point of view. And in order to do that, I will go through following points. So I will go a little bit in what is the definition of AI, and in particular machine learning, ML. I will show some examples. I will touch on some challenges. I will also present the EPO approach toward patentability of AI, mainly what we call the CII approach, with some very specifics related to AI. And last but not least, I will a little bit talk about how the EPO uses AI in our tools, in the PGP, which is our patent granting process. Now, this a little bit similar to what the previous presentation was about, is to position a little bit in the context of AI in a much broader context, what we call the Industry 4.0. If we see we are moving, or we moved already from automation of repetitive physical work into the, let's say, the robotics and the industrialization, and now we are moving more and more into, let's say, changing and automation of repetitive intellectual work, so the thinking process of the human beings. We can see it as well in a different way by looking. We used to have a computer in each home, in each house. Now we have a computer in each object. Just, I always say as a joke, just look in your home how many devices are connected to your router just by looking at the IP address list. You will be amazed how many equipment has access to internet. And also in the area of telecommunications, we are moving from connecting people to people, because to bridge distances, to actually connecting everything to everything. So any object is connected to any other object, from the kitchen to the office, to your watch, to your mobile phone. So and this is what forms the foundation of this increasing innovation in this area. Now, similar to Wipo DPO, we have done many studies here, and we are doing a lot of landscaping, and we are following all the technological trends, and we see that the market of smart connected objects is rising rapidly. We are noticing grow rates of more than 54% in the last 3 years. And there are a lot of things mainly driven by AI. So how come that AI now is a hot topic? Although we all know that the basics of neural networks are known from the 80s and even before. Now, if previous industrial revolutions were driven by steam or oil or even communication, this now is very much driven by data. Constellations of smart connected devices, faster wireless internet, big data, and artificial intelligence is using there. Because once we have such huge amounts of data, and this data represents content, it represents information, how can we and how even is possible to make sense of it? So we need some analyticals, we need very powerful tools who can analyze it and help us. And there AI plays a very good and important role. So if we look at AI in general, at DEPO, we divided into 3 categories, and I will give more examples in the next slides. I will start with the easy one, which was because it was already mentioned by my colleague Haley in the beginning and also by the previous speaker, is AI-made inventions, or when AI creates something and AI identifies itself a problem and proposes a solution to that. Now, in those cases, the EPO does not accept AI as an inventor. Our law is based that the inventor is a human being. There were 2 cases filed within the EPO. Both of them were refused at the first instance. Now there are appeals pending with the second instance. I put the numbers there on slides, and we are expecting a decision toward the end of December. So I will not talk too much in detail about this, but I will focus on the 2 other categories, which is the first one, which human-made inventions. So the human being creating an invention, creating solution, and using AI for the verification of outcome, similar like what we call modeling or simulations. And second group, which is inventions, which the human identify a problem or is facing a technical problem and uses AI to find a solution. Now, AI versus machine learning, just give you a little bit some examples. It's quite complex. It's all about very, very advanced mathematical models and formulations. Neural networks, for example, is one computational model which is inspired by biological neurons in the brain, so similar to how our brains works, where individual neurons are organized by layers, with different layers and different complexity of the layers and interaction between these layers. And genetic algorithms are another example of how we can implement an AI of a machine learning system, which mainly operates based on principles like in genetics, we call selection and mutations. This is all to try to find a solution to a mathematical problem in a very complex space. So how we defined artificial intelligence at DPO, and I think this was also mentioned in the speaking notes of my colleague Haley from Patent Law. Artificial intelligence encompasses computational system. So it's about a system to perform a computation with capabilities and or behavior which are commonly perceived as intelligent by human beings. There is a link of something which we see, it's a property linked to human being or human intelligence, and this computer system is able to get close to it. Yeah, however, human intelligence is much more complex than that and has different levels and dimensions. We can see there are human high-level intelligence levels where we are talking about reasoning, problem solving, adaptation to new situations. We have some low-level intelligence, which is just the automatic function which we are not even aware we are performing, like reaction, reflexes, sound, vision. And then we have something which is also, I think, one of the power of human intelligence, which is the emergent intelligence, which is actually our intelligence as groups. But you know, the sum of the effort of a team, it's more than the individual sum of the contribution. So by together, and we can achieve more. And this type of intelligence, which is also at least there are innovations there to apply it as well in practically what you call like swarm intelligence, or like examples of ant colonies or bees have similar behavior. It's quite interesting. So AI is still under development, and we have not yet seen how far we are going to get there. So machine learning is a part of, let's say, a field of AI which focuses actually on enabling a machine to learn and to adapt. So this is basically done by training. So we train a machine, and then when we put it in an untrained situation, we could at least expect that the machine will behave and will know what to do in that case. So in terms of mathematics, it's a mapping between inputs and outputs. It could be classifier. The inputs could represent sensors or data coming from a sensor. It could be, the output could be to control system, which is a vehicle, an alarm. It could be for predicting weather forecast, for example, or a financial model. And the way we train it, it could be by providing it with already known data or using actually data which letting the algorithm train itself. I don't see the chat, so if there are any technical problem, please let me know or speak up. I hope. Okay, so I need to be slower. Okay, I will try to see it. Sorry for that. Okay. So that is one example of how we can formulate an AI engine. It has an input, it has an output, and it's a function. It's a mathematical function, and we need to find the parameter W, which represents, let's say, the weights of, for example, neural networks. And we do this by providing known inputs with known outputs. And once we have that sufficiently, we can then use the system when it's fully trained with unknown input to see a little bit what we'll have. So that is one way of achieving an AI, of implementing an AI engine. Yes. Another one is used mainly in classification, where from the input, we don't define an output, but we define the output in terms of a class. We can define a shape or a color, or we can identify an object, for example. That is a second example. There are different ways. We could have an AI algorithm based on decision tree classifiers, where at each node, we can have a decision being taken statistically to detect or to achieve a certain classification of certain type of data. And we can have much more complex mathematical systems in AI. We can have vector machine classifiers, where it's about clustering groups of data and trying to maximize the gap, the space between two groups, to identify, like in this example, two classes, by looking at the difference and how to discriminate between two groups. And then the classical neural network, where we have many layers, many different nodes with different weights, and then we can optimize them and try to find the right way to be able to achieve the purpose for which this system was designed. And it is the more it gets closer to actually how our human brains functions. Of course, these are all very simple examples to show a little bit the way the mathematical model operates, and just to give you a little bit insight. In reality, it's much more complex. That is an example of a huge classifier based on deep neural networks, and neural networks, because the architecture is based on a neural network. Deep means that it has so many layers and so many interconnections and loops in between, which make it very, very complex. Now, in the past, it used to be simple to even implement some of the first neural networks using hardware, which each neuron is a chip or a computer. However, you can imagine with such very complex and deep neural networks, it's impossible to implement it in a hardware version. Although we have to see what the future with quantum computing one brings, it could be one of the possibilities. So basically, all these mathematical models are implemented using software. So it's a code. Implemented in the form and then runs on a computer, and when it is run on the computer, then the problem which it was designed to resolve is being solved. So why now everybody is involved in AI? Now, this has different reasons, and I think one of the new elements to the last years is that we have many new learning algorithms which are being developed. There is definitely more computing power available, very, very specific hardware like graphical computer processing units and tensor processing units. But I think the main drive here is the element of having a lot of data, because that's, I think, what's gave the boost. And there are many tools also, which are even, you can find them everywhere, like Tiano and Tensor, which enables anyone who would like to be interested to develop an AI solution to use them. So it is very easy to use. It's very easy to let's say, develop an AI solution. The only thing what you need is the data, and that's the challenge. Now, this is an example. This is how it looks like. It is a neural network in a few lines of code. So it's a program, and when it's run, then it performs this task. So which give you a little bit to visualize when you are talking about AI and legal right. What does AI really means? So it's a piece of code. However, this piece of code is so powerful that it's in some areas and for some specific tasks, it's already have achieved superhuman performance. It's even exceeded the ability of a human being. For example, in the area of image recognition, image processing, you see it on the left here, we are really now even better than human performance, and also in the area of speech recognition and speech processing, we have now AI algorithms which are much better than a human will be able. So this opens also possibilities for the future. Now, because of this ability, because of the availability of so much data, because of the huge potential of AI even exceeding the performance of human being, this opens the door to application in many fields, many technological fields, from speech to natural language processing to control of robots or drones or airplanes, financial systems, design of drugs and medication, diagnostics. So this is where, let's say, the key element is. It does not matter actually what are the inputs of the outputs of an AI engine. You just need to have the appropriate training data, and you can use the same engine for different applications. Now, if we look, for example, this is another example from the medical field, where it is about detection of skin cancer. And it's based on image classification of skin lesions, which is fully automated. And once trained, these algorithms can even work on a mobile phone. And 15 years ago, the system was good as an average, let's say, generalist, a normal doctor. Now it's even better than the best specialist, which means this task is being performed by an AI engine much better than the human being. Now it can get even more complicated if we look a little bit into the future. When we are talking about self-driving vehicles and scenes understanding and planning, that is another example where you see the complexity of the scene, where the AI is able to detect a cyclist, a pedestrian, a parked car while driving at the same time. So this was presented by Sasha Arnold a long time ago, and it shows a little bit some potentials of AI. However, we are not yet there. Just imagine applying the same AI engine in a very crowded city like Bangkok or Cairo, for example, and look how are you going to deal with this and what type of performance is needed to be able to achieve something very useful. There are other challenges as well in terms of training. If we look, for example, to just the fact of learning to grasp a particular object, and this robot is trained to do that. And we can see here, it looks for the robot as one piece, although here it's are different colors. And suppose we want the robot to only, let's say, grasp the cylinder, which is here given green. It's also important for the AI to also develop learning strategies to try to see what's the best way to train the AI. And that is something which is one of the key challenges in AI as well. So for example, would it be able to just say, first I will push this thing together, open it, and then it will be easy for me to recognize the object, and then it will be again easy to grasp it. So this strategic thinking in the training process itself is also some of the challenges, and where we expect many innovation as well in the future. Now, moving back to the EPO. when we look now into AI patent applications, we look at two big groups, what we call the core AI, and I put there in red the classification code, is the CPC classification code, this is G069, and here we have all things which will the innovation, let's say the invention is in the algorithm, the structure of the neural network, or the hardware, the tensor processing unit, or the graphical processing unit, the architecture, distribution computing, it's there. However, we have a second group where it's the applied AI, where we see where AI is being applied. And there, of course, it is very large because AI touches practically all fields. And we have done recently many, let's say, landscape studies at EPO insidely to see where this applications ends up. And we notice already that the penetration of AI to all, across all sectors, across all directorates. Just to give you a little bit an example, dealing with core AI, we have 6 teams of around, each team around 9 to 11 people, examiners treating only applications in this area, while here we have many teams and many directorates dealing with this part of technology. So now we go more and more into now the topic, is AI patentable? Can we achieve, if we innovate in AI and we would like to have a patent for it to protect our innovation, is this possible? The answer is yes, and here I will show you a little bit how does this work, or at least what is our approach at the EPO. Now, AI is a broad subfield of computer science that covers many different computer models. So it's about the computer model, it's about mathematics. This does not mean that in the application we need to put formulas, but we need to understand the model which is behind it. So inventions that are related to AI, it falls under the definition what we call computer implemented invention. Yeah, because you can develop a code of AI, but you need to run it on a computer to be able to use it. This computer could be a real computer, a laptop, a mobile phone, a smartwatch, or could be cloud, could be a server. So, and this approach of CII taken by the EPO is in order to discriminate between what we call software development and software innovation, where in software innovation we link to a technical problem being solved, to a technical contribution. So what is a computer implemented invention? In general, it's an invention, creation, whose implementation involved use of computer network, or any programmable apparatus able to perform the task, wherein one or more features of the invention are realized wholly or partially by means of a computer program. And AI falls under this, and therefore AI claims are treated like CII. And we'll see in the next slides how this works. So before we go into the detail of the process of assessing patentability of computer implemented invention and AI applications, we have to be sure that we all have, let's say, a consistent approach. Why is this important? Because patents are legal rights, and legal consistency and predictability are key to avoid the risk of litigations and high costs, especially when the environment is very competitive. Yeah. Now, at DPO, what we have done, we have, especially when we have noticed that there is a penetration of AI, CII in different areas of technology, we have a network, what you call CII network, contact persons and experts linked to all fields, from the medical to the mechanical field, to space technologies, to telecom. And those, by providing training, by communication, issuing documents, reviewing case law, looking at feedback from users, audit report, designed training modules, and foster a harmonized approach. So we can be sure that all our examiners treat these applications in the same way. Now, for the CII, we have what we call the two-herder approach. So there are two legal requirements which any patent application related to either a software element or to AI must bridge to be able to get a patent. Now, the first one is a technicality. Now, if we look at, let's say, what's the EPC, and the EPC is the European Patent Convention. It's our governing law with articles and rules says about that. There are some elements which are excluded from patentability. And one of them is programs for computer, but they are excluded as such. That's when they are as such, when we are talking about only the instruction or the set. However, if they are linked to a technical purpose or a technical application, then we can overcome this objection. So what does mean as such then? Or it means that if we claim a device of an apparatus, it's always technical by definition. However, when we are having a claim directed to a process or a method having steps, then we need to at least include one technical features. Otherwise, it will not be possible to get a patent for it. So if we look at, for example, some of the case law, some of the examples which were not considered technical. So just if we look for this, let's say, considering a natural language processing, which is purely linguistic, semantic, it's not technical, ways of doing business by trying to provide in some content to a client to be able to push up a certain product. So these are some of the examples which we can see in our case law, which were considered non-technical. However, although the terminology in AI in particular is well known to the practitioner and understood by most of the people, it still could be misleading and confusing sometimes. Because we see terms like support vector machine, but it is not a machine, or reasoning engine, it's not a real engine. A neural network is not a physical network. It's all a mathematical model implemented in the form of software code. Same with a node or a connection. So all these elements, all these wordings are looked at carefully at patent offices to be able to assess and judge the clarity of the claim, to be able to spot what is the technical effect there, to be able then again to see if this is first hurdle is being overcome, yes or no. So the first hurdle is related to a technical character. It's established without reference to prior art. We look only into the wording of the claim as it is. We don't look into the documents or anything else. We look only at the claim itself. However, it's very easy to overcome. By just mentioning in the claim that this method is being computer implemented, it's already enough, because we are already making a link to the fact that a computer is needed to be able to use this. However, it's still not easy for other requirements, because we have claims, especially when we see now and the claim structure is getting more and more complex, where there is a mixture type of feature, technical and non-technical, and how we are going to deal with it. Now, in this approach, it's always good to describe in the application, especially if you designed or if you have innovated, if you have a good idea and you want to patent it, to describe a concrete technical application. So just, it's not enough to just mention a potential field of application. Try to be concrete. Try to provide sufficient information, let's say, with respect to the application in the application itself, because we know one of the aspects you are going to judge is there is enough disclosure in the application. Is it possible for somebody who are reading your patent application to be able to perform it and to realize it? Because that's how is this patent system works. It's a contract with the public. In exchange of this monopoly right, we ask you to make your invention public. So even in cases when it's linked to a mathematical problem, for example, a simple example could be solving an equation, which is like X is B. Specify what does A mean and what does B mean and what does X represents, are there technical parameters? Is it a heartbeat, or is it temperature? Is it a physical entity? Yeah. And check when you describe mathematical steps that there are no mistakes, because as you know, once patents are filed, it's very, very difficult to change and correct mistakes later on because of the risk of violating Article 1232, which relate to added subject matter. So you see there are a lot of challenges, which on both sides, on the applicant side, the inventor side, the researcher, but as well on the examiner who is going to assess the patentability of such an application. So some of the tips we do is we look at the 2 dimensions which contribute to the technical character, and these 2 dimensions is that either your invention is adapted to a specific technical implementation, or it is applicable into a very specific field of technology. So claims directed to a specific technical implementation is, for example, how the AI algorithm is implemented by using, for example, a specific hardware configuration, specific way of performing the training, of generating the training data. And I will show some examples in the next slides. Just check how I'm doing with time. So does AI or MLM method steps contribute to the technical character of the invention? Yes, to the extent that in the context of the invention, it serves a technical purpose. So we always have a need to see this technical purpose in the description. Let's see. So it is not sufficient just to be able to just mention it in a general, on a generic form. We would like some examples to see some things which are more specific, so we will be able to judge it. So for example, if we look here, that is a patent application, a very simple one, which relates to a device which receives electrocardiographic signals with the purpose of detecting irregularity in the heartbeats. And however, the focus is to eliminate false positives. So there is a sensor provided, and the sensor measures, let's say, the heartbeat and provides a signal. And this signal is, let's say, feed up to this neural network, which is trained. So then after a certain point, when it's fully trained, it recognizes a regular and a normal beat, heartbeat's rhythm for a person. So if there is something weird happening, if the person is ill something, then an anomaly occurs, and then the neural computer will be able to detect that. So here there is a clear technical implementation. There are sensors involved. The signal is clear. So the use of this neural network definitely is considered to be patentable. We can have even much more complex, let's say, patent application. Again, this is again from the medical field, where there is a machine learning tool based on a vector machine and uses a Gaussian kernel function to be able to separate between, let's say, different categories of values which are measured. And this is encased by taking blood samples from a patient and looking into the chemical composition of it. So when we can also have a link to or an aspect related to algorithmic improvements. However, when it goes to algorithmic improvement, it's not enough to just mention, well, by using our mathematical algorithm, it uses less memory and it is faster, does not use a lot of computational power. So those things is not effective. We need to have a more specific technical implementation which enable that. So space, time, complexity are inherent to any algorithms, any optimization method, and cannot contribute just as such to the technical character in a generic implementation, in a very broad implementation. It has to be very, very specific. So we have to provide a more clear picture. How are the resources, let's say, used in that sense? So in this example, for example, I will show an enhanced machine learning digital image classifier. So the claim could look like limited to the purpose, for example. So claim X is a method for performing an image classification using a machine learning algorithm. Additional specifications as how the inputs and the outputs relate to the specific purpose is needed. However, the purpose could be specific and not in a generic type. So in this case, for example, the purpose is to classify pictures as being sunset, beach, or forest, a picnic, or the like. However, by looking into the prior art, it was perceived to be very difficult to spot actually a sunset picture because of the different lights and sun positions and so on. So in this invention, an improved classifier was proposed, which is realized by adapting the training data, given a set of images for training data. So what does this AI does? It took some training data and then manipulate it by changing the color in different ways to create more training data. And by having this augmented set of training data, the algorithm performs much better. So this is one aspect which is technical, which is in the area of image classification and image processing, and it's linked to the improvement in the training of a neural network, which is patentable. This is another example which shows a specific technical implementation. Again, in this part is a machine learning engine, which is cleverly implemented on a specific hardware. We see here, I don't know if it's very clear visible, but we see a graphical processing unit with memory and a graphical processing unit here. There are two, and there is a central processing unit here, and there are a lot. So this is all hardware, all chips. But here, the machine engine is very, very well implemented in a sense that it fitted to a very specific this. The advantage is taken from the fact that some of the operations, some of the mathematical operations are better performed on the graphical processing unit instead of the normal central processing unit, because graphical processing units are much faster due to their parallel architecture. So in this invention, a split of tasks was achieved, such that some of the preparatory tasks in the training are performed in another part than the rest. So again, here there is a clear link because it's a hardware implementation of a particular mathematical model. It could get a little bit, again, more complicated. Here we have a decomposition of supervised training of a neural network into a plurality of different sequence trainings in each training epoch. So there is a closed loop training where actually depending on certain parameters, there are different set of training data selected to train this. And again, this enhanced the performance of the neural network. So in general, if we look, for example, just a simple, let's say, AI image classifier. So suppose an inventor designed a classifier which is very good and able to classify image. There could be different category of claims linked to the same innovation. There could be a claim linked to generating the training data itself for training the classifier. There could be a claim which is related to how to train the classifier, or we could have a claim related to the execution of the classifier, so the performance of the classifier as a classifier. So one single, let's say, technical element could have many, many different inventions in it. Yeah. So that's another warning, and the risk is higher when you are dealing with AI, is that be aware that one patent application might result in then more than one invention. And since in the European Patent Convention, we are not allowed to have, let's say, a patent for more than one invention. Each one has to be claimed separately. So this risk is a little bit higher when we are dealing with patent application in the area of AI. So close to the end, we say, what about, let's say, the data, the training data? What about the weights we are using to train the neural networks, for example? Could this be covered by other rights, like copyrights or database rights? Should we keep it secret? Yeah. Well, this was already also discussed by the previous speaker, by Mr. Ulrich, and it is definitely here. Well, I'm not an expert in other rights. I am more involved with patents, but the general advice we give is if you have something which forms the core of your innovation, which you really want to protect, it's always wise to cover it from different facets, different perspectives. So I will always go for a group of IP rights together to make sure that this is connected. Now, my last slide is a little bit DPU as well. We are using AI. We are developing AI-based solutions in our tools. We have a program called Artificial Intelligence and Blockchain. It's part of our strategic plan. It's accessible through the internet. You can see all the different goals and all the activities which have been taken there. But this part is on the goal too. And it was in 2019 was created. It's a team of data scientists led by a head. I think he's with us today, and I don't know if he's present in this session, but definitely he will be present in the next session. So he can give you more detail on what we do in this area. But most, let's say, just in general, we focus on 3 pillars, which is computer vision, graphics, natural language processing, and machine translation. So we try to support by using AI the work of, let's say, our examiners, our formality officers in the search, in the classification, in spotting irregularity of applications to maintain consistency and high quality of our products. We have other things still under development, which are more for our users, like the applicant assistant program, and but these are still work under progress. So to conclude, yes, AI is patentable, and yes, there are challenges for patent offices as well, for applicants and inventors when filing a patent in the area of AI. In the following links, you may find more, let's say, information on the law, examples. There are our guidelines, and we are also now in the process of drafting new guidelines, which will be published next year with more and more examples. So this concludes my presentation. Thank you very much for listening, and I will be very happy to, let's say, take your question, if any. Either, I don't know if I give it back to you, Richard, so because I was not able to see the chat.
Thanks very much, Abderrahim. This way we have ended our two presentations, and it's time for some questions and answers. We have a bit of time, and although of course we are on Zoom and we are being recorded, let's try to imagine that we are somewhere near Chisinau in Cricova. It's a beautiful afternoon. We're having some amazing food and drinks from Moldova, the traditional ones. And we're having our little discussion about, not a little one, because obviously it's a huge discussion, but we're having our discussion on AI. And since I already asked one question to Ulrike, and I have since I am the moderator, I have that privilege of being the first one to ask the question. So of course, I'll use that privilege. And if I can ask you, Abderrahim, that because you were speaking about computer implemented invention, so AI patenting very often gets talked about in this context. Is AI really just like software, or is there anything else that makes it different, and we will need to take a different approach to this in the patent field? In your view?
Yes, well, that's all comes up to the definition of AI. So AI, it's artificial intelligence. We are trying to, let's say, describe an entity which is able to perform a certain task in a way which we link it to intelligence. Now, we could implement this AI engine using hardware. I think they were one of the first neural networks were really hardware-based, wires and computers connected. But because of the complexity, especially with deep learning, where we need multiple layers in the neural networks and multiple connections, it's very, let's say, not wise and costly and complex, and in terms of stability and heat and energy to do it in a hardware way. So most of the implementations are done in software based. So we program it. So that's one aspect. The second aspect is most of the tools are available to do it. I don't need to be an expert in programming to develop solution, but I can just use one of the available packages on the market or on internet to be able to develop it. The only thing I need is to adapt it to my own purpose, which means I need to get the data, and that's the trick. So that's the second thing. The third thing, I don't need a lot of computing power, because I can just use the clouds, and I can have there are service providers who can give me this ability to access their computers and to run my algorithms on them. Yeah. So all these things make that most of the innovation in that area comes from the developers, from the software, and from the application. Yeah. Now, when it comes to software, of course, the EPC, our law was drafted in 1973. It's a long time ago. At that time, a computer was different or looked something different, and software had a different meaning than now. So let's say the founding fathers were not aware of all this revolution coming now. So of course, we could say we need to change the law, but it is getting slowly, because we don't know yet also what the future will bring. So we are trying that by looking at case law, by looking at internal instructions and guidelines, and by experiencing that. Yeah. So from there, we come to this approach at DPO, which is the approach which is adopted also by other offices internationally as well, which try to see a consistent and a predictable way to deal with those patent applications. So at least when you file it, you know, as applicant, you know, as an examiner, what is expected from you, how the process look like. There are no surprises. So you know exactly what you need to do to pass all those requirements. Yeah. I hope this answers your question, Richard.
Absolutely, absolutely. And it brings me to another question, but this one I'll turn to Ulrike, because in the beginning, even in the welcoming addresses, we've heard that from some comments that on the one side, there's also that the system is prepared to take on AI inventions. But at the same time, there are, of course, countries across the world which are developing new policies on AI, including what Virak mentioned, that we have this this database available from the Wipo webpage. With these rapid developments and the revolutions, as now was also mentioned, of these technologies, do we need to act right now when it comes to development of relevant policies? And what were the views expressed perhaps during the Wipo conversation?
Thank you, Richard. I mean, that is the multi-million-dollar question, one of the multi-million-dolar questions that we're struggling with.
I don't have a multi-million, but I can offer a coffee in the afternoon.
we probably need that Moldovan drink to come to an answer.
Voilà.
I mean, clearly there's two extreme camps. I mean, there's certainly one camp that's saying the technology is evolving so fast and we don't know at this point where it's going to go. Any type of regulation might just hinder the development. And how do you regulate something? I think, as we've just heard, is I mean, the founders of the EPC, when they talked about software, certainly didn't think of the way how AI is done right now. If you take that to the extreme, how do we regulate something now that we don't know it's going to look like in the future? So that's one camp. The other camp is, of course, saying if we don't do it now, we're not going to be able to catch up. And that's certainly when we see, I heard a quote a while ago that really stuck with me, where someone said, the rate of change has never been as fast as it is right now, yet it will never be as slow again. And I like that very much, because that gives you a clear picture of the widening of being left behind and technology going ahead. So I certainly think what we're doing right now, the talking to each other, the exchanging views, the helping us understand, is the first step in putting something together, because if we don't do that, the gap is going to widen even more. I mean, interestingly, a lot of people on this call will know that Europe has just published the draft AI regulation. So we're looking at that. Maybe also unsurprising in what we've heard about AI and data and digitalization in Industry 4.0, that AI piece of legislation is part of a package to look at data. So there's some things to look at to see where it is going, but it's sort of saying, I think let's look at it and let's talk about it. Let's not let the gap widen too much, but clearly there's both views on what you can do or shouldn't do with regulation.
Thanks so much, Ulrike. And since it's a multi-billion-dollar question, Abderrahim, maybe you have the answer.
I think nobody have the answer, but one thing is clear. It's something which affects us all. So we need really to collaborate all. It's not something you do only in one part or the others. And we see different jurisdictions are facing different problems and similar problems as well. And everybody is following that. And so when it's about, let's say, AI, that goes beyond only the patent law or IP law, because we are talking now about your rights, which were linked to human beings. And we want now to give those rights to an entity which we need to, again, to define legally. So it's a lot of challenges for law practitioners and others as well. So I am as well curious and following that closely and looking forward to see what the future will bring.
Thanks very much, Abderrahim. And of course, I have a whole list of questions, but I will not be taking the floor myself. I'm turning now to our colleagues, the co-organizers, to see if there are any questions. And I see that Liliana has her hand raised. Liliana, please, the floor is yours.
Thank you, Richard. I will not try to monopolize the discussion. Just I have two questions, one to Ulrike and another one to Abderrahim. And if I may, I'll put the question in Romanian, in my native language. Deci, Ulrike a menționat că este foarte important să fim în pas cu dezvoltarea tehnologiilor frontier. Îmi imaginez că pentru a asigura că nu există acea mare diferență, discrepanță între cei care dezvoltă tehnologiile și care au cunoaștere foarte bună a ceea ce înseamnă inteligența artificială și societatea pe ansamblu, trebuie să intervenim deja astăzi. După părerea Ulricăi și a OMP-ului, care ar fi acele măsuri pe care trebuie să le întreprindem astăzi pentru ca mâine toată comunitatea să înțeleagă și să asimileze inteligența artificială și noile tehnologii ca pe ceva care este natural, care face parte din viața noastră. Merci.
Ulrike?
Yes.
First shot?
If I had the answer and I could bottle it, that would be a bestseller. But I think it's a really good question because it gets to the heart of something that I struggle with and that I think we need to together find the answer to. And that is, I look at it from an IP perspective, from an innovation perspective, and IP in itself can be seen as a quite subject matter technical, if I'm allowed to say, geeky in the best possible way, subject matter. And then on top of that, you add a layer of not just technology, not just AI, something like frontier technology that is evolving extremely fast. And I actually think having a base understanding of, like we heard about machine learning, what's a neural network, having to have that, to have an informed discussion. I have a science background, so I think of it as a Venn diagram. There's a small section in the IP bubble, and there's a small section in the technical bubble, and there is a very, very small intersection in the middle. But really, in order to foster innovation and creation in a world of increasing importance of IP in non-tangible things, we need to get the world and everyone into that intersection in the middle so they understand IP and IP becomes something that is used by everyone everywhere and the technology is. So I understand the question very well and something that I'm grappling with. I think that the best answer is to make things as explainable as relatable, to reach out, to have the conversations, to involve as many different stakeholders as possible, and that sort of closes the loop on why we're running the Wipo conversation in the format that we do, because it's quite an unusual and novel and new and for me quite exciting thing. It's not a standing committee. It's actually an open forum. It's, of course, we have member states, of course, we have the IP offices, but actually getting together the widest set of stakeholders, having the person on the street, having the academic, having the enterprise, and having them come together, for me, is one element of how we expand that Venn diagram in the middle to get people comfortable with both technology and IP.
Ulrike, thanks so much. Abderrahim, your shot.
Yes, well, I think there is nothing much to add with respect to what Ulrike said. And I also look at the chat and I see one of the things which is it's fear, and to overcome fear, we need to understand and explain what it's about. So we need to be more and more providing more information about what does it mean. The more we use only the two letters AI, and there's a very good question in the chat about the definition of AI being as well evolving. Yeah, the more people will have no clue what does it mean. And of course, if you don't know what it is, first thing your reaction will be to be scared of it or just block it. So I would say definitely look at it from different dimensions, technical, legal, what does it really mean mean, share. This kind of events really works as well, very well. And collaboration across borders, I think that's are the key element to overcome this challenge.
Thanks very much. You basically replied to the question which was in chat exactly.
Partially.
partially. I don't know, maybe because of the translation interpretation, I will just read out the question and then maybe Ulrika. So the question is, and yes, we have time for both speakers, from Dolores. Would you agree that the definition of AI is somewhat of a moving target? When Deep Blue came out, basically just using tree search algorithms, it was heralded as the ultimate AI. Today, we probably typically would not call it as AI, but rather think of some machine learning solutions such as deep learning, etc. What you also mentioned. Do you have some personal opinion what we call AI in, say, 5 years?
Maybe to continue on answering this question, which I think is a very, very good question. It shows already the issues we are facing, which mean there are different interpretations. People are, let's say, use the same words, but interpret it and understand it differently. And this is not bad, because this is in the sense it reflects their background. Because if you are a mathematician, you have a definition of AI. If you are a software engineer, you look at it differently. If you are working in a certain field, you look at it differently. But the moment we go into law practice and we go to IP rights, and then we need to have a legal definition, and that is what is the issue. So we have to all agree on a certain legal definition, because there are consequences linked to that definition. And those consequences, because either, for example, in patent law, it's a patent right, it's a monopoly right, it has consequences, actions linked to it. And there I see that we need to agree on it, because it's not sufficient that each one has a legal, let's say, definition in its own territory or in its own region, but it's something I think we should globally look at it. I don't know if that answers at least the second part of the question.
Absolutely. In fact, before I turn to Ulrika, immediately can I jump in with another question to you, Brahim? So do you think, because of these uncertainties when it comes also to the definitions in patent AI field, means there's more reliance on, for example, trade secrets?
I will not link the two of them. I will not say uncertainties. I will say work in progress, because there are a lot of things going on, but we need to find agreements as well. And that is also not easy, because we are talking now global scale things. Yeah, a trade secret is another tool which, as an inventor, you may use to protect, let's say, your innovation. It's not always easy, because even trade secret has some challenges as well. How to keep it secret and how to avoid that somebody else come up with the same idea. So that's a different topic, maybe for another talk. Yeah. So I will not say there is a very indirect link, but I will say not directly linked together.
Thanks so much. Ulrika, back to you for the question of 5 years.
So I'll take the question on the 5 years, because I was a scientist in the past, but not a computer scientist, although I did some quantum chemistry at some point that I never thought would come in useful, but it does right now. The question of where do we think AI might be in 5 years' time? There is a fascinating group in Geneva that, Richard, you might have come across, called GESTAR, the Geneva Science and Diplomacy Anticipator. And for anyone that hasn't come across it, it's definitely worthwhile having a look at it, because they are looking at the big technology trends in frontier technologies. There is AI, there's quantum computing, there's the brain-computer interface. And they're working both with leading scientific experts to anticipate where the technology might be going. I think they do 5 years, 10 years, 15 years. And they try and link that up with the diplomatic challenges in coming back to the question we had before, and how can we keep up with regulation when something is moving so fast. So the idea behind it is very much to look at where science might be going in 5-10 years' time, and helping us already anticipate where we could slot it to solve some of the issues. There is a scientific anticipatory brief on AI for anyone that's interested in the current edge thinking of where their science might be thinking AI might be in 5 years and 10 years and 15 years. And certainly the words of general AI are being used in there. And certainly AI that is much less likely or much less needy of data, that is actually self-training in some ways. So it's an interesting world coming up. So, and I'm not the expert, but anyone interested in the prediction where I might be going, that's where I'd say have a look.
Thanks so much, Ulrike, and thank you. Thanks also from Dolores to both of you. I'm turning to the organizers if perhaps there are any other questions that came up in not the general topic. Sorry. Liliana, Ulrike, could you please share with us the contact details to the diplomatic anticipators? We will, of course, I'm sure. I don't see any additional questions, and I know that we are supposed to have a short break for coffee before we would have the next presentations. And although, of course, we did not enjoy the Moldovan food or drinks, but I do hope that in the next 2 years, I really hope so, that we'll have that opportunity to revisit. But definitely we have a lot of food for thought after our discussions and after our presentation. So I thank so much Ulrike and Abderrahim for their presentations. And thank you also, of course, for the organizers in facilitating this discussion and session. And I give the floor back to you, maybe, Liliana, for an announcement that we have a coffee break or we continue. I leave it up to you. Thank you so much, everyone.
Thank you, Richard. Thank you, everybody that is still here in the virtual conference room. I'd like also to thank Abderrahim and Ulrike for their presentation, and to ensure that we'll come with more questions as we have your contact details, and I'm sure there will be some other occasions to discuss more in details the issues that we just tackled. I have quite a lot of questions, but considering the time, we will probably leave it for the next session, next meeting. In the meantime, I'd like to suggest the following program. We may, of course, announce a coffee break, but we, the organizers, and of course, if there are some availability from our speakers from the first session to remain with us till the next session will start, then I would really appreciate this, because maybe somebody wants still to get into and to have a chat or to raise some questions. We may share some ideas on how to proceed, how to go forward with this very tricky and very fancy right now AI concept. And if everybody else agree, then we'll waiting for everybody back in 10 minutes from now. And we will start the second session on artificial intelligence as a tool for improving IP services. But till then, I would like to ask my colleagues and our speakers to stay here if they can still, and to have a chat on, or to have a talk on AI as a general concept for future development of new technologies. So thank you very much. See you in 10 minutes, or you may still stay with us. Okay, great. So before starting the second session, I'd like to, in my quality as organizer, I'd like to introduce our colleague from the European Patent Office, Antoine Reddy, who is our country manager and our counterpart in the European Patent Office that is responsible for all our cooperation. And I'm taking this occasion to welcome you here, even virtually. And I will be pleased to have this session moderated with you. So the floor is yours, Antoine, and please everybody join us for this second session of the Innovation Conference. Thank you.
Thank you very much, Juliana. It's first of all, thanks to AGEPI for organizing this event. It's a very important event. And it's a pleasure to moderate this session on artificial intelligence as a tool for IP services together with you. So in this session, we will welcome 4 speakers. First of all, Michal Zinski, who is Senior Machine Learning Specialist at Wipo, and who will update us on Wipo initiatives. Dolores Modic, I hope I pronounced correctly, from the KnowING IPR project in the Danube region, who will address the developments in the field of linked open data. And we will have the pleasure to listen to David Vega, who is data scientist and senior solutions architect at EUIPO, together with Fernando Peregrino, who is data science lead specialized in natural language processing, both from the digital transformation department of EUIPO in Alicante. And they will present design and trademark search, eSearch Plus, and TMView based on image recognition. First of all, before giving the floor to Mr. Zinski, a few words about AI as a tool for processing patent applications at the EPO. We use artificial intelligence at the EPO in the fields of computer vision for patent figures parsing and matching them with the abstract. We use natural language processing and machine translation for pre-allocation of files to the most suitable examiner, for pre-classification in the cooperative patent classification, and for pre-search before starting our patent prosecution process. We have as well a tool for automatic translation between our 3 official languages, English, German, and French. We have in this audience my colleague Alexander Klenner, who is the EPO head of data science, and we may reply to your questions on the EPO practice later on when we do the group discussion. But without further ado, I would like to move now to Michal Zinski. Thanks for your patience, Michal. I was long in my introduction. And to Wipo, Michal, the floor is yours.
Thank you, Antoine. It goes without saying it's a pleasure to be here. Thank you very much. I'm going to share my screen. Please let me know if you can see my presentation. Okay. So my name is Michał Ziemski. I'm the Senior Machine Learning Specialist at Wipo, the World Intellectual Property Organization. And what I would like to do today is to give you a short glimpse at some of the tools that we use internally and that we actually have developed in-house that are using machine learning techniques. And just to start off, I would like to introduce our team. The Advanced Technology Application Center goes with a very nice acronym at TAC. And the goal, the mission of our team is to explore machine learning techniques in intellectual property. And you can see we have different specializations. Some of our colleagues work more on machine translations, others on speech or on image. So what I normally do during such a presentation, and I think this already came up during the discussion in the previous session, is when talking about artificial intelligence, the question is, what does artificial intelligence AI stand for? And I would like to precise this a little bit, just so that we all have a common understanding. For me, AI means deep supervised machine learning. Therefore, we take a lot of data and we use neural networks to automatically teach a machine to perform a specific task. And even more so, the data that we need to use the data that we use to train such machines needs to have certain values. So we need an input and an output value. That means for every question in the training data, we already need to know the answer. So we have a long list of questions and answers that we then use to teach a machine. And this is also why it's been called supervised. And a nice way how to break down the areas of activities in Wipo that are related to machine learning or to AI is by the type of data that we use in order to build the systems. And this is a wide span, including text, speech, and image. So I will show you a couple of systems. It's just a selection of the most relevant or biggest ones that we currently use at Wipo, but there are a lot of initiatives and a lot of projects currently ongoing. So what I would like to start with is Patent Scope. You may actually know Patent Scope. It's a big patent search database with nearly 100 million documents inside. And these documents can come in a variety of different languages. So for example, this would be a search result for monkey, and it comes back with, on the left, a description of a patent, and on the right with a list of claims. And me as a non-Chinese speaker, the only thing I could deduct from these two pictures here is probably that on the right, we have 5 claims because these use Latin characters. So wouldn't it be nice to be able to, on the fly, somehow get access to the information inside of this text, even without speaking Chinese? And this is exactly what Wipo Translate does. It's an embedded widget into the website that can be used to, on the fly, translate from one language to another. And here we can see that I was actually right. The title of the content was claims. And now I could start reading about the different claims. Of course, the machine translation will never be perfect. There are errors. It may be imprecise. Some describe translation even as an art. But in this case, it would allow me already to have a general understanding of the content, and it's better than not seeing anything. So also to give you a little bit more history about Wipo Translate, it has been in place since 2011 and is using neural networks since 2016. Just to put this a little bit into context, Google launched neural networks into their production machine translation just 2 weeks before Wipo did. So it's fair to say that there is a lot of expertise and experience specifically on machine translation in Wipo. And this is probably also the reason why Wipo Translate is definitely competitive with other machine translation providers for in-domain texts, meaning that content that belongs to the area of intellectual property. And by now, Wipo Translate consists of more than 100 different models. And these are not just different languages. And we can see a long list here, and there's even another upcoming language, Polish, but also language models which are specialized, which are specifically trained to be experts in some domains, like the patent domain. And as this is an in-house development and is fully based on open source, we can adapt it in theory to any domain or any use case of translation, as long as there is enough data available to train the models. Also, one big advantage of Wipo Translate is that we can really handle confidential information. So even when the data is absolutely not public and it needs to stay confidential, Wipo Translate, as it is hosted on site, can translate this. Quick overview how this works. So in the first step, we need to collect a lot of the data. And actually, these are segment or sentence pairs of 2 languages, and these are then used to train a neural network that becomes a neural machine translation model. And once the network is trained, then we can take a sentence in one language, give it to the network, and the promise is that it will come back with a translation. Now the question, or a question that comes up frequently is, yes, machine translation, it's not perfect, so why not human translation? And if we look a little bit at the volume involved just on patent scope that Wipo Translate has to deal with, I think currently we're around 3.5 million words translated every day. And 2/3 of that is Chinese, Japanese, and Korean into English. So very quickly looking at the scale of this, it becomes clear how useful machine translation and automated translation is. Another interesting data point would be the fact that just in order to keep up with new incoming patent applications, one would need to read 7 patent applications per minute all the time. And this is something that would be very difficult to keep up. The next question that typically comes is, yes, but why do we have a customized machine translation system? It's a lot of work. It needs to be maintained. It's not easy to train. But if we look at some figures, and as long as we stay inside the domain of the patent documents or the domain that the translation model has been trained for in Wipo Translate, even if we compare to Google Translate or DeepL, which are considered one of the main actors in the field, Wipo Translate is able to be competitive or outperform such translation providers. And you can see on the diagrams here, top left is patent data. So these are customized model for technical language. On the bottom left, it's for the internal language division. So this is a more conference or meeting oriented languages, writing reports to meetings. And as I said, there are various use cases. So from our experience, for a tool to be useful, it's also very important that it's well integrated. So there are many ways how Wipo Translate can be used. There is direct integration with cut tools for translators, web interfaces. There are queues where, for example, Word documents can be dropped into and they are automatically translated. Widgets which can be embedded in websites and then automatically translate the website, and many more. So this was Wipo Translate. The next tool that I would like to show you is Wipo Speech to Text. And this is a speech recognition model that was trained primarily on Wipo conferences and later on augmented with additional data from other organizations, with the idea being that after a conference finishes, it automatically takes the video and creates an automated transcript. And I would like to demo this to you actually live. So I opened up one of these web pages. This typically comes up on the same day after the conference. And just to show you the level of quality of the recognition.
I'm very pleased to open the 9th session of the Committee on Wipo Standards and to welcome all of you this meeting all over the world. Like other recent Wipo meetings, this committee is convened in hybrid format. Nevertheless, we are inspired by your commitments to continue to work.
So what we can see and hear is that Wipo Speech to Text has created a word-aligned transcript. So I can click on any specific word here, and I will jump automatically to this place in the video.
Convened in hybrid format,
which is very useful because I can directly access a specific point in time in the video. And the content also becomes accessible and searchable. What we can also see is that it's not always perfect. I think in this case, this should have been hybrid, but the system recognized hybrid. I'm not exactly sure what this would mean, but also it's debatable if the system acted correctly or not, because this certainly is a non-native speaker, and this can also pose difficulties to a typical system. If I go to another example here.
Madam Chair, I'm referring to the documents W/9/4. As Chair already introduced, this document includes a working draft proposal for metadata management.
So we can see that Wipo Translate, even for heavily accented non-native speakers, has a pretty good accuracy recognition quality. And this is one of the strengths of the system. Another interesting feature is that we recently developed a multilingual model. So it's not only capable to recognize several languages separately, but it can also smoothly go from one language to another.
Programme à l'Office de la propriété intellectuelle du Canada, où je suis le directeur général de la direction des programmes à l'Office de la propriété intellectuelle du Canada. Tant pour travailler la modernisation de nos systèmes, à la fois système client et système destiné aux employés. Avec l'arrivée de la COVID-19, certains de ces plans ont dû changer. I will now switch to English, and if you want to proceed to the next slide, please.
So you can hear, again, a very heavy accent. I think this is Canadian French. The first sentence was in French. The second sentence seamlessly goes into English. And there are many, many use cases for what can be done once you have the text of a video or of an audio. It can be used as the basis for a translation, for a verbatim, but also for full text search or for live captioning videos. So Wipo speech to text is already in full production in Wipo, and it has been shared with other organizations. On top of that, what we also have is the possibility to take the recognized text and through machine translation, translate it into a different language. So here you can see an example where we have English text that was translated into Chinese. So this is very interesting also as a solution if there is no language-specific audio stream available, for example, through interpretation. And here a very quick look at the search engine. So I can do a textual search and the system will directly allow me to jump at a specific point in time in a specific video where I have found the occurrence of my term. An interesting point about Wipo speech to text is the data that was used in order to build these models. And here you can see the breakdown for English and French. So in one case, we have around 2,200 hours of audio and corresponding transcripts as training data. And then the second case, around 1,400. So this is not a lot in comparison to what big players in the field like Google or Amazon have at their hands. But through the data quality, the specific pre-processing that was done at Wipo, and also the careful selection of the data, already this amount is good enough to be on par or even beat similar systems. And here we can see that actually the data was contributed by various international organizations, and there are also parts which are just publicly available data corpora. And again, the topic of customization. So here we can see it's a breakdown of the quality of the text recognition. And you can see that the lower the graph is, the better, because it means the less errors are made by the system. And the orange and blue graph are the ones from the Wipo system, and the others, I think, are Google and Microsoft. And this is not a very recent evaluation, but what I want to show you is on the right side, there is this big bump between orange and blue, and going down is better. Blue is the newer system, and this means that through including some data that belongs to the domain of the test documents that were used, already we see a difference in quality. And this is quite important because if such solutions, such systems are shared with other organizations, for example, it's always important and it's always an advantage to fine-tune the models to a specific case. So an example for speech to text would be acronyms or specific terminology that is used on specific topics or by certain organizations. The next tool or topic I would like to show you is classification. And as an example here, I would like to take the IPC, the International Patent Classification. And just as a quick introduction, this is a hierarchical system of language-independent symbols for the classification of patents. And you can see that it's from a very general classification, it becomes more narrow and narrow through classes and groups. And what we have done is we took a lot of data, and based on titles and abstracts, we built a system that can then predict the IPC classification of a new text. And this is used, for example, at Wipo to classify automatically non-patent literature texts where such a classification is not available. And it would be quite costly and a lot of work to classify them manually. We have a similar system for CPC classification. We have trained models, but these have not been used yet. And of course, it's always possible to do custom classification systems. For example, for Wipo Green, where an individual classification schema exists, and as long as there is annotated data, so as long as we have these examples of documents and we know which category they belong to, we can try to classify, to train a new system that would then predict the classification for new documents. To give you an idea about the accuracy of such a system, so for IPC, for top 5 accuracy, and top 5 here means that out of 5 predictions, 1 is correct. We are around 98%. For the subclass, so this is the most general classification, and we're still typically better than 80% if we take the full IPC code. So this is already useful to how we classify documents. But again, it's not perfect. The system will make errors, but at least, and this is also an advantage over human classification, it is consistent. It is more consistent in how the classification is applied. Now moving to the third area of data, which is image-based. So the first one that I would like to show you is a small tool which is actually publicly available, and it's the Vienna Classification Assistant. So here we have a small web page in which we can drop a small image, and I take a classic cat picture. And behind here we have a image classification based on the Vienna classification. And through the user interface, I can now drill down through the suggestions that come out of the image. So here it thinks this is an animal, cats or other small felines, so with a fairly high confidence level. So in this case, this works fairly well. The main idea of this tool was to classify trademarks and maybe a little bit designs. So if I take a different example, something a bit more technical. So this is a sun umbrella. It gives me back a classification of tobacco, smokers, and many more. So it doesn't look very good at the first glance, but inside we have a subclass, which is open umbrellas or parasols. So again, the recognition is pretty good, but it already kind of shows that if I don't stay very close to the type of data that was used or the narrow focus of what the tool should do, I could run into problems. So now if I take another example, and this is a small octopus toy. It's good. It recognizes this is probably a toy. I click on animals, and here we already see it's making some mistakes. I think octopuses comes at 4th position, but this is definitely not the dog. So I think it becomes clear that for every system, it's also important to be specific, at least at this stage, to clearly depict the purpose and the focus of what should be done. And here also other examples which highlight why image recognition can be a challenge. If you look at the image on the top right, this is a good example for multi-label images. So it includes a lot of different concepts. We have a car there, taking a shower, brushing its teeth. So it's even for a human, it could be difficult to really say what's going on there. Also different classes or images that don't belong to a specific class or belong to several classes. Or on the right, we have an animal that actually doesn't exist because it seems to be a mix of several ones. Still at Wipo, image recognition is quite important. And one big example of that is the global brand database. So it's a gateway to more than 45 million records. And it has a function that allows you to search for similar or identical trademark images. So here is a screenshot of the user interface where I can drop in an image. So I have a leaf shape in a black circle. And we can see that the system finds similar images. And these are not just similar in shape, but similar in concept. So the level of quality of search results is pretty good. And in this way, a user can really check for a trademark, whether it's already known to the database or not. Another example, and this is still an ongoing development, is image similarity for industrial designs. And this is a gateway to more than 13 million records of industrial designs. And now you can see this is the user interface where you can look at particular designs. And here the challenge is that one design actually includes several images of the same design from different perspectives. So now we're currently developing an image similarity for this purpose. And you can imagine this gets tricky very quickly because you can have the same design with different views. So on the top right, you can see 4 images, which are very different from each other, but they actually represent the same thing. I think this is a tripod for a camera. And of course, you can get very similar images for very different designs. So here we have 3 different images at the bottom, which kind of look the same shape-wise, but they're completely different things. I think the first one is a wheel. The second one is a lamp. And the third one, I don't know. So we already have a prototype and we hope to go in production fairly soon. And the idea of what the system does is that we run a query. We have 3 images. Here, the black umbrella, the bottom left. And this is used to run a search on the system. And on the top right, you see the results. First design, second design, third design, and fourth design.
Michel, excuse me, I have the difficult task of being a timekeeper as well. So if we can give 5 more minutes, I think we will near.
Yes, I think I'll be.
Sorry about this.
No. Thank you very much. So these were some of the main initiatives that we have, but obviously we also have a lot of AI projects in Wipo. And what we typically try to do is to run these in close collaboration with the business side. So even though I would describe some of our activities as applied research, there always needs to be a business reason that drives a certain development. So what we try to do is to tailor the systems to a specific needs and specific expectations. And we also accept that sometimes things don't work. It's not always possible to solve a certain problem with machine learning, maybe because there is not enough data, maybe because the technology is not advanced. An example for that would be a chatbot project where we tried to build a chatbot and the quality of data was just not good enough. And the chatbot was actually pretty good in the sense that it was polite, but it did not answer the questions that were sent to it. Other examples of small projects, but that worked well, are small classifiers or workflow facilitation tools for human resources, similarity or filtering tools to clean up data. And as I mentioned, our strategy is really to try out things. So we do a lot of quick prototyping just to try to see if something is possible or not. And then we also accept to fail. But what we want to do is to fail fast. So to know quickly if something is a promising development or not. So in this sense, we also try to work very closely with the academic network to stay on top of the most recent developments and try to apply these for our scenarios. And obviously, another important topic is sharing data and creating synergies, especially on data, with other interested parties, with other organizations. And in order to be flexible in how technology and knowledge is exchanged, we really focus on using open source technology. So with this, I would like to conclude my presentation. I hope I'm still on time, and I'm open to any questions you may have. Thank you very much.
Thank you very much. Liliana, do you want, or I take it?
Thank you, Antoine. I just wanted to mention that maybe if there is no urgent questions to be raised right now, we may go to the other speaker, and then we have this questions and answers session at the end, and then we can debate freely on whatever it's going to be presented by the three speakers. So if you agree with me, Antoine, then I would suggest to give the floor to the next speaker, to Dolores Modic, and to listen for her presentation, and then to the EU IPR, and then to discuss and to comment and raise questions.
Very fine, thank you.
Dolores, the floor is yours.
Thank you. Can you just confirm that you hear me, and then that you'll see my
we hear you quite well.
That's good.
Yeah, hear well. Perfect. Perfect.
Yeah, good. Let's go here and start. And can you see it as well? And then I'm all set to go. Yes. Okay. First, thank you to AGEPI, of course, for kind of thinking of us and reaching out also in terms of this event. We're always honored to be able to contribute. And of course, also congratulations for putting together such a wonderful event. A little thank you to Liliana for stepping in at the beginning. I did not understand, but I'm sure you've done KnowING IPR justice. And then my last thank you is basically a very a personal one, right? Thank you for inviting me. Thank you for giving me the opportunity to share some of our thoughts that are mostly derived from our work at KnowING IPR, during KnowING IPR project, especially in terms of the tool. I think Liliana must have mentioned it's a wider initiative, right? With the also intent of raising awareness, raising competence, and so on. And I will a little bit base my thoughts also on some other endeavors that we're doing, especially those related to linked open data. And yeah, like I said, it's an honor to be able to do this. And we had so many exciting areas covered already today in terms of artificial intelligence and innovation data and IP data, right? Mikhail was talking about the machine translation, then moved into computer vision, right? And I know the speaker after me will talk about image recognition topics. So again, this computer vision. I want to thank Mikhail a little bit for giving me a little bit of a foot in terms of reminding us that it's really a whole process going from inputs and outputs. So what I want to do a little bit during this talk today is also address a little bit the question of our data sources, our data quality, understanding our data, linking between different data points, being that within the same data sets or between data sets, which will be a little bit different than most of the solutions we were listening to today. And then, of course, consolidating our data and all the kind of the little points and opportunities where we can get support by machine learning and AI solutions. So I thought this was an apt imagery to start today, since Christmas is coming up. And I won't be long in kind of repeating two things I think we can all agree upon, right? One is that IP data has a vital role in helping firms to both accelerate and optimize innovation processes, and for policymakers and researchers to understand innovation systems. The other thing is, which I think we can all agree on, is that we live in the world of big data today, right? And if we think about big data, we typically characterize it in terms of the 3 V's, right? The volume, variety, velocity. And more recently, we have some additional V's, such as high veracity, high value. Not to stay on this aggregate level, just to mention, right, a few things. In terms of a wider scope, right? In 2020, for example, Google announced that it will open up to public 25 million data sets. Then in terms of what we're looking at, right, we have, we were listening now to this idea of image recognition, right? How can we harness imaging inside the patent documents? There's also other super interesting things going on, right? I think one of the long-term questions was how much of the knowledge that's embedded in patents is incorporated in products, right? And you have a group in Switzerland doing something on this and also now publishing first results. It's also a very dynamic landscape, right? Those of you who come from research, from the research area, and have been exploring what's happening in terms of new science advances in innovation through publication data, have perhaps used the Microsoft Academic Graph, the MAG, which will be discontinued in December. Luckily, someone else is picking this up, the Open Alex initiative. But all in all, right, we're definitely not lacking either the data itself or the data sets. But what we want is, and I said this, one of the V's is this high value. So what we really want is this worthwhile insights and benefits, or in other words, what we want is actionable knowledge from it, right? And thinking about the actors, right? On one hand, we have humans with this kind of intuitive sense of semantics, right? We are kind of able to identify, interpret a lot of contextual clues, that being textual or visual or so on. However, we are pretty poor in doing this at the scope and scale and speed that is needed by today, rather complex data landscapes. And so, of course, what we do is we rely on computational agents. And we rely on them, like I said, right from the beginning, from the discovery through integration tasks to analysis tasks. Another thing I want to put out as a kind of a little context, right, is there's a lot of things going on, and I'm always happy to hear about new things, right? And here is just I've selected this one with no particular reasoning, but for example, Siemens has this patent explorer, which basically allows you to refine patent search with domain-specific model. And it was trained on their patent portfolio, which is huge, with 70,000 patent applications behind it. So the question is, how open are these solutions? So it's excellent to hear that of all the Wipo and EPO initiatives, right, where we can expect that these tools will be available to wider public, right? But also in terms of this one, right, when you have behind it a database of 70,000 patents as your internal data that you're kind of plugging in, that will give you something most likely. But this breakdown with smaller samples is always present. In terms of technologies, right, we talk a lot about databases, techniques, software tools, but thinking of systems, right, and information systems and its theory, there's also this emphasis always on people, right? And I've been recently at a patent semantic workshops as one of the panelists, and a co-panelist of mine brought this, I believe it's a tweet with him, and it says, you wake up in 1918, what job are you qualified to do? The answer, patent attorney. The job hasn't changed that much in 100 years. My point is that I don't think that's true. If it is, it shouldn't be. And it goes so in terms of patent attorneys, as well as other people that are dealing with patents. So I welcome these kind of conferences, right? And also inside the KnowING IPR, especially in this last work package we're doing now, we're trying to contribute somewhat to this as well. Okay, I said I'm gonna talk a little bit about the kind of initial stages, and as everything, this also seems pretty simple at the beginning, right? If you think about it, and I'll just go through kind of from sourcing to the output, right? We have our source data, could be a single database, could be multiple databases, which we trust more or less. We can treat all of them as equal, or some can be just auxiliary data sets. Cleaning and parsing as the next, and then thinking about this on the example of a person and multiple data sets, right? You choose your key. I'm going to use person a little bit more to exemplify some of the things I'll be speaking about. But in terms of knowing IPR, basically the basic entities, publication, and then you think about all the attributes that you might grab in relation to that entity, or if you have a query, right? What is my data and what it can give me? For consolidation, of course, this is the point where we do rely on algorithms, and we come to our kind of output solution. For this next one, I'll use a very stripped down semantics of the knowing project, but kind of to think back, right, on this problem of avoiding kind of garbage in, garbage out situations. What you want your sources to be, if you are linking multiple already existing data sets, is of course you want quality in them. Which means you can either trust them completely, or you can actually have doubt in some of the things. For example, if they already consolidated some data, for example, they've decided person A is same as person B. Do you trust it? Or are you rechecking and you're not only thinking about, oh, I'll merge this maybe with something else, but you're maybe thinking, oh, maybe I need to think about splitting this person, right? Here you can see is in the knowing IPR, it's basically using various types. So you have the patent data and the publication data, and it's also grabbing from the web. Again, immediately after that, you're basically thinking, okay, now I've grabbed this, but we said this the data today is dynamic. So immediately you are developing new functionalities, right? Check if source updated, download source data, crowdsource site, supply to module, and immediately check for the duplicates, right? And we're just at the kind of data acquisition model running into the source database, right? And the other part is the next one, right? Thinking about data analysis and processing module that will actually bring you to the knowledge database. And I'll run through a few slides on the first part and on the second part. I'll use our Disney friends for this. Well, some are Disney, some are Time Warner friends. And like I said, a very simple question of persons. So we know in this case, right? Like I said, for the beginning, we have some questions that are very simple, right? If we choose as an entity, a person, for example, here we know that Donald Duck is not the same as Daffy Duck. And we know that Mickey Mouse is not the same as Jerry. But it's not so clear cut, right? Because the questions is also, is Duck DF actually Donald Fauntleroy Duck or not? And as for any steps, we have a variety of approaches to think about. Is person A same as person B? Should I be connecting these two data points or not? I'll point out to kind of the geolocational ones. For example, there's a whole literature on that. but also other, right? Who do they collaborate with? Can I infer from that if this is the same person or not? Their affiliations and so on. I like the, one of my friends loves this, this quote, right? About kind of experience without theory being blind, but theory without experience being a mere intellectual play. And with new machine learning solutions, we still mustn't forget that we need to know our data. And I just want to show you this with this ANSCOPE quartet that you might know, right? Obviously, we see here 4 different situations. But if we would look at it from a kind of descriptive statistics point of view, we wouldn't really see that, right? Like Michal, when I think about the next, well, or when I'll talk about the next 2 slides, I have in mind supervised machine learning, not unsupervised. As Michal said, right, this is where we are able to kind of compare our results with somehow with expected results. And the problem is, of course, we can overfit or we can underfit our models. Both present a problem. With overfitting, right? We will lose the necessary flexibility. And I'll just give you, I'll bring back my Mickey Mouse or Minnie Mouse in this case example, right? We are often very happy when we have very detailed data. However, imagine Minnie Mouse just getting a new lead role, or let's make it more of a patent thing. Maybe she's the new lead engineer. And so she just moved to a better apartment from Beverly Hills to Pasadena. So when we think what we're instructing our algorithms, our models, is we need to keep in mind to allow for this flexibility. Okay, like I said, when I think here about machine learning, I'm thinking about supervised machine learning, right? Where when typically you would have a training data, you'll have a validation, some kind of a test data. And the point I want to make here is that it's also important that we kind of share the information on our processes as much as we can. Of course, there's limitations, but also we often put a lot of efforts in kind of producing these golden data sets, right? Something we can compare our results to. And we are sometimes reluctant to share that, but it's both things are kind of avoiding double work for others. Okay, I have a few minutes in the end. I'm gonna use them a little bit to illuminate another point, and this is going to the last part, putting this data in the real world, right? Or if we would think about modules, this would be the report generation module and some kind of application at the end. And it is so for the KnowING IPR project that this exists. Sometimes the results will be in the form of bulk data. Sometimes the interface is more or less user-friendly, right? But behind it, right, are also these principles of FAIR, and they've been around also for quite a while. I think Horizon 2020 must have had for several years now also these guidelines to to fair principles for data, right? So making sure that in the end, whatever we do is findable, right? Which also goes hand in hand in having rich metadata, making sure it is accessible, right? Using protocols that are standardized, right? I'll address a little bit on my last slide, the linked open data in specific, which uses the usual HTTP protocols. And then interoperable, that's why a lot of when we think about linking data between different types of data sets. And of course, KnowING is one of several, right? You have Lens as well. You have guys from Inventions that do great work and so on. But right, you're trying to use vocabularies that are again standardized. You want to really make sure that things are reusable. And the last E is actually not a part of the original FAIR principles, but rather our colleagues at Lens have pointed out that solving problems informed by science and technology requires also the understanding of the context, of permissions, of capabilities, right? And thinking of that, when we think about AI support, we want it to be as transparent, right, as possible, easily detected, easily seen through, to avoid this black boxes that we are faced with as much as possible. And the other issue is being sustainable. We had a discussion with other providers of different solutions a couple of months ago. And this also presents an interesting issue of how can we make sure that our solutions will be sustainable and will be available to users in long term. I said I'll say a few words about linked open data, kind of relating to another project of ours, the IPLOD. But I'm going to use it to kind of show that whichever your starting point is, you kind of come to the same or very similar problems, right? This idea of linked open data has in its vision, right, that the World Wide Web will be treated and researched as one database using machine-readable formats. And this will allow sharing and reusing of existing data, or kind of being a path to data democratization. And it goes back to Berners-Lee and a note of his. And probably you know the name Berners-Lee, kind of one of the fathers of the World Wide Web. And again, here, right, things that linked open data is interested in, again, structuring data, uniform entity referencing, this time through this uniform resource identifiers, multi-source data utilization. So thinking about patent data in this example, but what else can I connect it with to gain business intelligence or to give context? A little different is this decentralized approach, where each data provider actually takes care of its own data set. However, that also brings us to the other side, where availability and accessibility can be a problem. We've done in that a little pinging algorithm looking at this availability. One other thing is it's a little bit sometimes hard on the eye. So if I would show you this, you wouldn't really be too excited about it. So it's oriented towards machine readability, not so much human browsability. So getting to know what's there can be a problem, like I said. And although it says linked open data, a lot of LOD sources are really not adequately interlinked, which means it's very much a work in progress as well. I'm gonna finish here. I just kind of want to point out two takeaways, right? One would be that there are opportunities arising from using machine learning solutions and AI solutions, right? Throughout the whole process, from inputs to outputs, right? From identifying the data to consolidating the data to analysis. And the other thing the other takeaway I'll try to leave with you is that with our excitement about these solutions, we mustn't forget about really understanding our data, understanding what it can give us, and perhaps understanding what it cannot show us. Thank you.
Thank you very much, Dolores. Just in echoing what you said, it's a fascinating presentation. We at the EPO are working, and it's already in production, on linked open EP data. As you know, we exchange on this, preparing this conference. And each data at the EPO is given an URL to identify patent applications and publications and other resources present in patent data. And with this, you can incorporate information about EP publication in web pages. You can connect with patent data from other publishers, and you can download data to create your own database. And you can combine patent data with business or non-patent literature data. So it's really an expanding field. The EPO and other IP offices, other players are investing on it as well. And it's a fantastic initiative you presented to us. Liliana, maybe we have questions, or we park them for the end, as you mentioned, and we move to the colleagues from EU IPO.
Thank you, Antoine. Thank you, Dolores, for your presentation. And it was a pleasure to see once again our project here and the results of the project brought to such a big audience. And we would like to thank also our partners, CPO and Wipo, for providing us with the data in order to make this experimental, let's say, project really bringing it to life. As to the questions, I think we have some questions raised and answered on the chat already. So we can move probably to the next speaker, and also to encourage participants to raise their question, to put them on the chat, and we'll turn back to them during the question and answer session. If I may then introduce to our audience our colleague from the European Union Intellectual Property Office, David Vega, from the Digital Transformation Department. David, the floor is yours, and we are looking forward to your presentation.
Thank you very much. Well, let me share presentation. I think I cannot share the screen. Let me check. No.
It should work, as you will have fast capacity quality, so it should work.
Yeah, one moment.
No problem. In the meantime, if somebody wants to make any comments on the presentation that we just heard, no, it's okay. So we are moving to the EU IPO presentation. David, please.
Okay, so thank you very much for the opportunity of sharing our journey, let's say, with some AI initiatives, like in this case is image search. And thank you for all the presentation. That it was very, very interesting. So, well, some time ago we started in UIPO for building an image search algorithm that tries to get all the trademarks and finds from a query user perspective the most relevant ones. So for that, I mean, for sure, we will be prepared for putting those things in production. So in parallel of doing the AI, let's say, pure models, investigation, and let's say, build the brains and the models, we started also looking into how we are going to put this into production automatically and without losing anything. So we started to building the pipelines that will gather all the images. We extract all the information of the different databases we have. Also, we pre-process all the images. We calculate the features, that later on I will explain what is it, and then generate different brains. We call brain, but these are machine learning models. And this was done using a tool that is open source, that is Apache Airflow, that you can define like pipelines. It calls DAX. Well, and what is a brain, and what is or let's say definition of the model that tries to abstract to give an abstract representation of an image. Well, we use convolutional neural networks, and we use complex, let's say, convolutional neural network, and at the end, what we get is a vector that describes the image. I mean, in this vector, we have, I think, like 2,000, more or less, 2,048 features that describes this image. Okay. With that, sorry. It was the image that. Okay. So we have the input image. Then we extract those features from different brains, and then all the features that we previously extracted are like in a n vector in n-dimensional, let's say, space, n-dimensional space. So we get the query image, we extract the features, and we position this query image into this space. Okay. So, for example, in that case, the closest image is in that spot. Okay. And then what we did, if you do like a zoom, okay, you will see where is located this query image, and we start the k nearest neighbors. So the nearest k elements, and this will be the output of one, of a brain, and this gives you the nearest image from the query image. What we did that because usually the convolutional neural network are used for classification images. But if you have a classification or you have a number that represents that images, usually you should measure the distance, I mean, in the query time to all your database. And this is not performant, because if you have a large database, it is impossible. So what is the plan? The plan is to have a kind of way of locating the neighbors of an image and then returning them. So what exactly is our system? I said we build several brains, and those brains are, let's say, capture different things from the images. So what we build is a single point of entrance of the image search engine, and we call it the orchestrator. The orchestrator will manage what brains are we gonna use, and also it will get the OCR service to locate the text and to know what text is in the image. And also we aggregate the results of the different brains, the OCR service, and we consult the metadata, and all of this is aggregated and returned to the user. So it's not like a visual similarity image, for example, is usually used. I mean, we are taking a lot of things in consideration when the query image is reached to the orchestrator. Also, we analyze the complexity of the image to see if it's simple, complex, and the orchestrator is deciding what to do. And one important thing for the previous slide, where we locate the neighbors of the image, in order not to measure the distances between the images, we use a face index, which is a library from Facebook that basically is an index to be able to measure distances, but in a very, very fast way. And now we have, we have a metric that was used here in the UIPO to measure Invention, that was our provider for image search. And these were the numbers we had with Invention. It started at 39%, now then 42, then 48. And currently in the first version that we are deploying, we have around 46%, and I'm sure this will increase rapidly. Also, this metric was not very representative because it was images in the database and with some bias. So we started to look into another metrics, because I see that having a ground truth of a visual similarity image is very, very difficult. You don't have a metric, and the similarity is very subjective. So having a accurate metric is something very difficult. Here in this metric, that is not 100% good, we can see that what we are doing here is the query image is the contested image of an opposition, and we expect to find the earlier right or vice versa. The query image is the earlier right, and we expect to return the contested sign, the contested trademark of the opposition, of previous opposition cases we have at the office. And then you can see here that the performance for less than 300 results are a little bit worse, but then it is better. Then future work. As I said, we are using nearest neighbors, and this has some problems depending on how are these images stored, let's say, in the space. So for example, you can see here that the nearest neighbor search is getting results that are probably not relevant, and we are going to explore in the future the diffusion method that tries to get not just the nearest neighbor, but the aggregation with a little bit more logic. This has a problem of speed, but we have a, well, it has been published an algorithm that is also good at speed. And another future work, we are using, for the brains, we are using Inception 2 and also EfficientNet, and also MobileNet V2. And what we see in EfficientNet is that it's trained with general images, and sometimes the important parts of the images that EfficientNet is taking is not the most relevant ones. So for example, for you to understand this image, the red areas are the most relevant ones when the features are extracted, okay? The first column is just the image. The second column is EfficientNet by default. And the third column is a proof of concept we are doing, trying to modify EfficientNet to give more attention into the relevant parts. For sure, it's not perfect, but it's a new path of exploration for us, because as you see, for example, in the third image, I don't know if you can see my mouse, but in the third image, which is in the top, this chef or something like that, the relevant information, it is outside the text and outside everything mostly. And in our approach is more just in the people and in the text. So we need to check, and we need to follow this path for sure. Also, we have developed the 6-tier database detection to detect flags and detect signs, and it's working really well. And we have more things in the designs area. We have developed some algorithm that, for example, check if there is a neutral background in the design or not. Just, for example, the first image is okay, and the second one is not okay, because the difference between the object and the background is not okay. It is more or less the same. And also we are generating algorithm to detect if there are more than one part in the design, or more than one design in the same image, which is not allowed, well, depending, but at least to give this information to the user and to the examiners. And well, just this is the roadmap of the project AI implementation. We have been working in a lot of things also about NLP. We have published a service, for example, for goods and services suggestion that is used in the easy filing currently. We are launching chatbot, 2 chatbots. We are launching also other tool for goods and services comparison. Well, we are working internally in other things that are not going to production soon. And that's it. Questions?
Thank you, David. Thank you very much for the presentation. I suppose we just finalized the list of our speakers with the communication that we're supposed to be according to the agenda of today's conference. Acum, înainte de a da cuvântul lui Antoine să preia discuțiile, aș vrea să invit toți participanții să adreseze întrebări, folosind prilejul de a avea aici specialiști de talie internațională în domeniul instrumentelor de proprietate intelectuală și cei care de fapt sunt printre primii care lucrează la dezvoltarea și îmbunătățirea sau dezvoltarea unor noi instrumente și îmbunătățirea instrumentelor actuale. Acestea fiind spuse, vă invit să adresați întrebările fie în plen, fie prin chat. Antoine, do you have any questions in the chat or any raised hands?
Well, if there is time, maybe I can show a small demo.
I suppose you still have time, even from your time slot. So please, David, we are
Okay,
looking
perfect. Okay, so you see this?
Yeah, we see drag files of picture open.
Okay, perfect. This is a development environment. So for example, I'm gonna throw this image. We are not, I'm not gonna test the sister database, but I'm gonna show you what is returned. So this is the query image. It's not the same as this image. That's why it's not the first result. But what is important is that we retrieve this one, for example, that in the previous, in the past had an opposition case with that. And it's getting the concept also. Also, if we look for this image, that is the Pepsi logo, but just black and white, you will see that Pepsis are returned, and not only with this logo, but with different ones. Also, this is another opposition case. This is the original image, and this had an opposition. And this is a kind of fake logo with another text. And in this case, we are not retrieving anything relevant. But if we use another brain, you will see that we catch the leader. So sometimes it's like a trade-off of measuring and getting the right balance between all the things. Here, for example, this is also like a misspell, which is Marlboro instead of Marlboro, and we are getting the good trademarks. And well, just the last one. this is not registered. It's the logo of Octoprint, which are used for 3D printer, and the concept of the octopus is also there. So that's it. Well, so thank you.
Thank you very much. I see a question from my colleague Alexander Kleiner, and we'll give him the floor now.
Yes, thank you very much. Thank you for the interesting presentation. I was wondering, for the inception net that you showed, what is actually the target label that you're using? Are you using Vienna codes for encoding the image similarity, or is it something else?
Where for the metadata, you mean?
Mm-hmm.
Yes, we are using Vienna codes. We are using, but not only, we are using denomination, we are using the OCR, we are using the applicant name. We also find the possible oppositions and the possible opponents and all this stuff. And then we mix this up and we throw it, let's say. So that's the thing. Having a balance among all these elements sometimes depends a lot of the query image. If it's simple, if it's complex, if it has signs, how the relevant are the signs.
I'm asking that question because in your demo, and I found that very interestingly, it was a very abstract elephant head that you posted there, and on the early ranks we saw a comic kind of depiction of an elephant, and I think that is either a very good conceptual capturing of what is actually depicted, or there is a heavy bias towards the, for example, Vienna codes that could explain such an effect as well. Because there's certainly, I'm not an expert in Vienna codes, but there is certainly a code for like an elephant within this system, right? Or an animal, and then it's very fine granular. And I would just wanted to understand what is the target, what's the objective function in the network that would allow such a nice conceptual capturing of the image content. It's very interesting.
It depends. For that, to trying to balance that, what we did is we use a common technique that are used by NLP retrieval system, that is make a very small query and then use the n first results and then do another query with all this stuff. So if you see mostly representative Vienna codes there in the first query, then you will do another one giving more weight to the Vienna codes.
That makes sense. So super, thank you.
You're welcome.
Thank you very much. Unless there are other questions to David, I would like to turn to Michal. First, to congratulate about one sentence that I will keep in mind. You said fail fast to innovate faster. I think if we change one word, fail fast to learn faster, you may have a good definition of AI or of some patterns in AI probably. And I have a question for you, Michal, if you're still there. I hope you're still there. I don't see you, but I hope so. Otherwise, my question will be lost. But it's about Wipo Translate and machine translation in general. In which direction you will see as the next development going, unsupervised learning, or I do not know if Michal is still there.
Yes, I'm still there. Can you
okay,
hear me?
good.
Okay, great. Yeah, so that's a very good question. I think what we already do and what we definitely will continue to do is domain adaptation. I think for us, the future is really in customization and trying to be narrow about the problem you're trying to fix. But at the same time, and I think we heard this also in the other presentation, it's important to try to put more and more context into the models, into the translation even here. So for machine translation, that would mean document level translation, or even to use additional information that you may have about a certain document. And looking further, I think the next steps will be multi-language models that process several languages at once. Even thinking about having a huge model that can do a lot of different things. But that is still, I think, a little bit further away, as well as unsupervised learning, specifically for machine translation. But I think these are the things we're currently looking at.
Quite ambitious and promising. And concerning a tricky question, maybe concerning the use of AI tools, did you find already a way? Did you think of a way of finding how to quantify how much it improves IP administration? Did you find a way to assess this or to?
That's a very good question, because looking at something like Wipo Translate, I mean, I think we can see very clearly the benefit of it, that information becomes readable and accessible, but it's difficult to quantify. But for example, for a project like Wipo Speech to Text, where we started to automatically generate transcripts for meetings, it's much easier because actually it was decided to not produce manually typed transcripts and translations anymore. So it becomes more visible where the economies come in and how the workflow also changes. It was actually a game changer to have such transcripts available very quickly. And I think the use case changes accordingly with that as well, because it's less of an official document and more of something like a tool that can be used quickly and is more interesting for various stakeholders. I hope this answers or gives an example to your question.
I think very much so. I turn to Liliana. We may have questions as well. Otherwise, I will address Dolores.
I'd like to mention one thing. Și o să fac în română, având în vedere că vreau ca acest lucru să-l audă și colegii mei. Cred că este foarte important că am avut aici prezentările celor 3 oficii mari de proprietate intelectuală, pentru că pentru oficiile similare oficiului de proprietate intelectuală din Republica Moldova, dezvoltarea unor instrumente care să încorporeze tehnologii atât de avansate, care să lucreze la dezvoltarea unor noi tehnologii pe domeniile foarte importante pentru noi, care să ne ușureze și să ridice calitatea examinării și acordării titlurilor de protecție. Este foarte important. Noi avem resurse limitate și faptul că oficiile internaționale, cele mari ca OMPI, OEB-ul, Wipo, lucrează pentru a crea acele instrumente de care avem și noi nevoie și care ne vor servi nouă, atât astăzi cât și mâine, pentru îmbunătățirea calității serviciilor pe care noi le oferim solicitanților, este foarte important. Și de aceea cred că astfel de platforme, astfel de discuții sunt foarte importante pentru ca noi, cei de la oficii și, desigur, și comunitatea științifică care la un moment dat va putea să acceseze aceste instrumente, sunt foarte importante și mersi pentru prezentări. Pentru moment atât.
Thank you very much, Liliana. The initiative was on your side, AGEPI, today, so not on our side. So thanks for putting this up. A question maybe to Dolores. Maybe you would develop a bit on the iPlod platform, the iPlod project you mentioned when we discussed. So to address the issue of linked open data and patents, so this connection. So if Dolores is still here,
I am. Yeah.
Would you like to develop a bit on this?
I don't want to be disloyal to the KnowING IPR project, which I think is a great initiative as well. But yeah, so the IPLOD was basically a project that was financed by the EPO. And kind of the idea came from, I think it was 2017 when there was the conference, and the guys from EPO came. I think it was Gert and Martin came, and they were talking about releasing this data, this LOD EPO, and we thought, oh, this is exciting, right? But our question was, okay, so you will release this data in this format when each data piece will have its own identifying URI, and then what? So our idea was, okay, let's pick up and let's see what else we can maybe do with this. And so we had our core database, which was the EPO's LOD. And then we were looking around, kind of shocked that there isn't a nice signpost just saying, oh, check here, right? There's a little bit is there, but a lot of it is kind of missing. So our next step was basically to choose kind of our core second data set, which was the Springer Nature. Because we believed at that time that they will develop further this ecosystem, and luckily we were correct. And then we were looking at other sources such as Grid and so on. So we really wanted to kind of do a little bit of a proof of concept. Also, EPO was then thinking about, oh, okay, can we connect this data with something else? And you have a neat little demo version of what it's called, EPO LOD, where they're connecting patent data with DBpedia, which is basically the LOD version of Wikipedia. So it's kind of, you know, things are going on, kind of other than the problems I was addressing already in my presentation, right? There's also, I think, still a relatively early on or a small community. And of course, you also have all these competing approaches. So we might think of, you know, linked open data as an path to continue. We can also think of linked open data as an approach where we can learn things, and we've learned a lot. We also are just now basically sharing our algorithm with a group from Switzerland, from ETH, and they'll actually pick up on some things as well. So not just preaching, sharing, but actually sharing the work. So for us, it was and is super exciting, and we're always on the lookout for new offerings as well. Kind of a few enthusiasts behind the whole initiative, which is always good, long term. Yeah.
Thank you very much. Thank you very much, Dolores. So we will be looking forward progress in that direction and enhance connection between patent data, non-patent literature data, business data, and we will be here with you. Probably I see no questions in the chat. Probably it's time for me to hand over to Liliana and to Mr. Rousseau, our host, for concluding this day, and thanking you so much. On EPO side, we learned a lot today, and we appreciated a lot all the interventions you brought together.
Thank you, Antoine. I think it's we may close now this second session, and before offering the floor to our Director General for closing remarks, as I see also no comments or no request for floor. I just wanted to mention one thing. I think Michelle mentioned that machine translation will never be perfect. I'd like to thank you on your behalf, on the behalf of all speakers, on my team behalf, and the agency, our interpreters. They did a great job. It was a very difficult job. It was very technical, and we appreciate very much them for facilitating our communication today. So thank you very much on behalf of our entire team for your job today. With this, I'd like to give the floor to our Director General, Eugeniu. The floor is yours.
Mulțumesc, doamna Vieru. Țin să apreciez faptul implicării tuturor în acest eveniment. Din câte am auzit eu și am ascultat, toate prezentările sau raportările au fost destul de interesante și mă bucur că au fost suficiente întrebări, pentru că noi trăim într-o era întrebării, dar răspunsurile le aflăm peste mulți ani la unele. Și cred eu că a fost interesantă această conferință internațională. Vreau să mulțumesc tuturor celor care s-au conectat, în special moderatorilor și raportorilor pentru informația utilă care a fost prezentată, dar și colegilor mei din AGEPI, cât și proiectului KnowING IPR, care a fost suport pentru organizarea acestui eveniment, și partenerilor strategici, Organizația Mondială pentru Proprietatea Intelectuală, Oficiul European de Brevetare și, nu în ultimul rând, Oficiul Uniunii Europene pentru Proprietatea Intelectuală. Sper că a fost suficient de interesant pentru fiecare. Vă mulțumesc frumos pentru tot, pentru informație mai ales, și sper să ne revedem în curând la un alt eveniment. Atât pentru astăzi, vă urez o seară frumoasă. La noi este deja seară. Numai bine!
Good evening to everybody, wherever you are. Thank you.
Goodbye, and thank you very much.
Thank you very much.
Mulțumesc.
Bye.
Enjoy the afternoon, everyone. Thank you so much.